And we're back for more cast. Okay, let's see. What did we do yesterday? I did mutation and I did generators. That was working, right? How about we start today by making sure that they don't break in the future by turning all of these things into the test, because I forget to run my examples. Of course, I do have a way to write tests using nicks and checking them. Consider having a start screen so people don't miss the beginning of my stream. I was having a start screen before, and I don't know. Maybe it's like, I don't know. It didn't, like, I at some point I just got rid of it because I don't have that many viewers anyway. So like you know, the few viewers that come early anyway, you want them to be staring at a starting screen. They just go back then and find something else who is not starting. It's like watching like an ad. Kind of annoying a little bit, in my opinion. But yeah, maybe should reintroduce. Maybe it was too long, like before it was like 5 anime starts with 1:30 opening. Yeah, but what should be on that opening then? Like the anime openings are pretty cool to watch though, right? Then I need to like write a song and like do some dancing, record that into a video, and that would be my starting on my stream then, right? It should be something that's actually entertaining then, and not just a screen that says that the stream is about to start. Anyway, I want to start by making sure that I don't break some stuff in the future. So I have this thing, next flake check, that is going to build my application and then run it on some things, specifically over here, the next kast check ID. So the ID actually is a test that is currently failing. So let's see what is wrong with my test called ID. Boom, like this. Test ID. This is the test, right? This is the file that I'm trying to write. Right, this is my program. I do it in line here. ID is a for all types, a function from X into X, and then I am debugging the ID this into that. And they said that the characters differ. Character 6, line 1. I can make a better error, I guess. I can make a better error, I guess. Somehow, somewhere. So this is the definition of a test where I actually run the tests. Is over here. Here's how I'm doing the test. I'm just using the CMP command to compare the two files, right? So the CMP command does not show me the things, right? Um, right? If I do cmp flake nix and cmp flake lock, those are the two files that obviously differ. All it says that the two files differ, byte 5, line 2, right? What can I like do this cmp compare two files byte by byte? Can I show it maybe like the line where they differ or something like that? Like the status is 0 if inputs are the same, 1 is different, 2 is trouble. Print differing bytes. Maybe this is what I want. If I do this, shit, what was it again? Print bytes. Print bytes. Okay. Byte 5 line 2 is 151i and 42 quote. Yes. So, okay. All right. That's kind of better, I guess. They just show the 1 byte. I would like, I don't know, if they showed me the entire line or something, maybe I should use something else than the CMP. So yes, I have a 40, which is a space, and then I expected a 72, which is a colon. So I guess the problem is, if I go into the REPL and I say 123 int 32, the problem is that over here it says only one colon, right? I am like, when I'm writing my programs right now, actually I use the double colon for specifying the types, but in my debug output I'm just using a singular colon. dbg 123 int 32 is going to do the same thing, right? Right. So I think I'm actually going to change then the way I am doing the DBG to, yes, because like things are supposed to be consistent everywhere. Let's see, interpreter, and somewhere would I do the DBG, I show the value, then I do a double colon, then I do this, right? And then also the same in the REPL, which is in the main over here. I also will use the double colon. Right? 123 int 32 is 123 of type int 32 with a double colon. Okay, and now if I try to do Nick Flake check, it's going to rebuild stuff and then check, and then all my tests actually pass now. So the problem was that the expected output here was double colon, but I actually got a single colon. Hello, Nigel. Nigel is first, apparently. All right. So this works. Let me also bring in the other tests. So I have examples, right? But examples, they don't really like, they are not having like, so I think for every example, I will do a corresponding test, right? For example, if I have a test, hello over here, this says print hello world. But how about instead of using the built-ins to file and doing the inline here, I want to like just use the dot slash examples slash hello.ks, right? So this is like the actual file. I can just start with dot, right? And then the expected output is actually going then to be, do I need a slash n if I do this syntax, by the way? So hello ks is a file that does print hello on one line and then does a world on a different line. So I guess the expected output here is going to be hello, enter, world, enter, right? Xflake, check. End of string reached. Getting status of hello ks. No such file or directory. Wait, what? Can I not read the something from the... This file definitely exists. Can I not read from the outer directory actually in Nix? Get it? Oh, it's example, not examples. Okay, I just did a typo, right? This is examples. Hello, okay, there we go. That makes sense. Okay, so I actually run the actual example that I listed in my examples and expect this to be the output. Okay, nice. Let's do the same with the other examples. So we have examples, for example, mut, which does the mutability, which is also very similar to a hello world. Let's write this as test/mut.nix. This is going to be running the mut.ks, the expected output for the mut.ks. Is, so what are we doing here? We are saying that we have a hello. We're saying hello. I think I will not print this. I'm just running the function twice, once before the mutation and once after the mutation. So it should be also like a hello world technically. Hello world. I'm just using the lowercase letters there, right? That works. Next, we have examples called Fibonacci. For the Fibonacci example, I think, since this is like, this is just defining a function, right? For line numbers in the code snippets in the website, you can use line nos in the markdown, like line nos. Okay, nice. Is that a feature of Zola or of a markdown in general? Hide lines to hide lines. Specific lines. You must specify a list of inclusive ranges to hide it. The warnings is HA lines to highlight lines. Line no start. Specify the number for the first line. Defaults to one line knows. Nice. Not going to work on the website though, I think, right now. Okay, what I want is to make a test for the Fibonacci. Since I have this example, right, I want to make sure that this actually works. But I do not want, I think, to turn this into something else. Because the way we run this is I do just run with a REPL, but I still do the example slash Fibonacci, right? So I run the Fibonacci. I know what the Fibonacci is. Fibonacci 10 is going to be 89, right? So but the just running this file directly does not actually try to compute anything, right? Yeah. So what I want is to be able to make tests test slash Fibonacci dot nix. So this test is going to have the source, which is the Fibonacci, right? And then I guess maybe I will have not only the source, but I will have well, I guess I should be able to like run multiple sources, basically, right? Or something like that. For now, maybe it should be like source and like uh in REPL, for example. In REPL would be something like maybe I make a string here. I do Fibonacci 10, right? I do deep. Should it be in REPL? I don't know. Let's do this. Fibonacci 10, right? And I want the output. The expected output is supposed to be 89 colon in 32, right? That's what I'm expecting here. Or I can just like run a script after. So this is like the source that I want to like import. Maybe this is my actual source. Right, dbg Fibonacci 10, but this should be like import or something like that. Is that possible? Let's see, flake next. So here is what we do, right? Have the test. I have a name of the test. The test has a source, and potentially it has an import too now, right? So I just do test dot import, or if it's not there, then it should be just an empty string, right? So that I do not try to run anything before the actual source. Maybe this flake check. Well, I don't know. It looks like it actually worked. I mean, the Fibonacci was actually not run because I need to add it to the Git. Otherwise, the Nix does not know about the file. So let's do it again. There we go. So now it says that I have a syntax error near unexpected token. This. The setup. The syntax error is in my... Is it because of the import? Is import like a keyword or maybe? In next, no? The error messages. This error message is not that great. This is a bash script. The bash has the syntax error. Oh wait, hold on. Source. Wait. I know why. I know why the Fibonacci. Because this is supposed to not be a line. This is supposed to be a string. So built-ins dot to file test. Yes, and this is the source. Okay. Fibonacci is checking and Fibonacci works. So if I try to like make that this is like an int64, for example, and just try running the test again, and it's going to say that yes, I expected a 6, but I got a 3 at this specific byte. Okay. Yeah. Good enough. Good enough. Good enough. All right. Anyone knows of a better command than the CMP? So I'm trying to like compare the output using the CMP Linux command to compare the two things. It just only shows me the byte where the things differ, right? Should I use the diff instead? Diff like next like dot log, right? But this is too much of a diff, right? Or is it okay if this is my entire thing? And if I do diff like nix, then it's just like, yeah, I guess like maybe I just do this instead of a CMP. Let's see. Just do the diff q. Q for just seeing it different. What does q do? Man diff dash q brief. A report only where files differ. No, but this does not tell me what the difference is. I do want to see the difference, right? Like, I already know if the files are different or not using the CMP command. Diff is just like showing me the actual diff like line by line, which is better than the CMP actually. So I think this is what I want for the testing purposes, right? Tests Fibonacci. So once again, if I say that the Fibonacci was expected to have an int64 here, and if I try to run my test, then it will say that there you go. I expected an 89 with which was in 64, but I actually got 89 which is in 32, right? And it only shows the actually lines that differ, right? I think this is better than the CMP before. Okay, nice. In 32. Good. Next, I have other examples. Let's see, we have a guess a number example, right? Guess a number example. Let's do a guess a number example. Don't need to add diff as a dependency now. Looks like diff is in the is installed already. There is a bunch of things already installed since I'm doing it inside the Nix. Like they're like stdenv. It's like Nix stdenv. It's installing a bunch of things there. The standard environment. Like I have bash. Tools provided by SDN. We have the C compiler even available to us. We have find, we have diff CMP, we have SCD, grep, awk, tar, gz, xzig, numake, bash, and patch command. This is what is available to me. Unless I go completely from scratch, which I could, but I don't think that's necessary. Okay, so Fibonacci is tested. Let's create a new file, and it's going to be tests slash guess a number. So guess a number is a thing where source is dot slash examples slash guess and number dot ks, right? And we will have the expected output to be built-ins dot to file just call it expected output, right? The expected output is something something. If I just try running this, let's see what's going to happen. So what's going to happen is it says failure, cannot finish. It's trying to parse something and it cannot finish it. So actually the KS file, wait, hold on, is wait, hold on. It does not run right now. Just test, guess a number. Yes, there we go. It actually is broken. Okay, so at line 10, something is broken right now. No notifications. Hello, Infinite Coder. Oh, did I forget to put it in the Discord today? Yeah, I think I did, right? Whatever. Guess a number over here. So at the line 10, this over here, this loop is no longer working. Yes, because this is actually no longer working because I removed the syntax for the anonymous closures like this. Maybe loop is going to like be an actual keyword. Right now it's a function that takes in a function which is the body of the loop. So in order to do this correctly, I would need to do loop fn like this, right? I'm not sure like about the priorities here. This might actually still not work. Yes, because the fn is the lower priority than the application here. Okay. Loop. Okay. So I think just because of that, I want to have a dedicated syntax for the loop then, which is going to do this automatically for me. Maybe. Again, line 10, 14, 15. And then, yes. Can I do this? Void. Yes, I have to do this right now. And then 28. 28. This is the same thing. Main is also a function which takes void and does this. And then over here we have another loop. Okay. Okay, yeah, let's actually do the loop syntax right now so that we don't need to do this. If let loop. Let's go into the standard library. Loop. I think similarly to the for syntax loop syntax loop impl, because I need to use a different word there than the actual keyword that I'm going to introduce here. So we do loop and then an opening bracket and then a closing bracket and then the body, right? So loop is going to be something like this. I'm doing the same priority 3 like that, and then for loop, and I have the const loop impl is a macro which has a body, and then I return something like this. I do So I have the loop over here. Yes, this loop is just like this function, right? Loop fn. I guess I call it a loop fn then. Here. So the loop impl is calling the loop function using the function which has the body inside here. Right, that's what I want. She was doing compiler dev in peace yesterday until I got a notification of a game jam. I completely forgot about it, but it's a 72-hour jam where with the theme patterns and limitation, geometric shapes in art. And I also want to participate in another game jam which started about 6 hours later, theme overheating, and it has to be a hard speedrunning game. Just at the same time, and I suck at pixel art, but I have to draw. Not a robot. You've been streaming for 15 hours straight without understanding what Kuvi is doing. You've been streaming? Tank Toes? 15 stream streak without understanding what I am doing? Wait, what? You don't understand what I'm doing here? I'm making a programming language. You want me to explain what I'm doing right now over here? I'm making a macro. So like the loop. So that the loop is not a built-in thing. It is similar to macros like in Rust, but with custom syntax instead. So that it is like in Rust, this would be looking something like loop exclamation mark, and then I have the body there, right? But because this is looking ugly, I can have a custom syntax which would look something like loop and then the body, and this is going to be translated into, because I have written this macro here, it is going to be translated into loop fn, which is calling this loop function with a new function with the body inside. You know, it's just me translating the syntax of this into the new syntax of that. That's how the macros work here. They're based on the AST. Body is the AST of the body. So I replace it over here using the dollar. What is a macro? Is there also micro somewhere? Is loopfn the same as while true? Yes. It is. It is. I might like make it a dedicated thing. Like in Rust, it is a special thing. The loop. We have for loops which iterate over like something that can generate values over a generator, but the loop function is more like a while true. Yes. In context not found. Okay. Was the wrong button. In context means a width. This means a width. Width. Okay. So I actually found a bug. Okay, there we go. Guess 5. Okay, it still does not work. Inference failure. I expected string and string, but I got int32 and int32. Okay, so I actually did break something. Will there be a do while? We can have a do while too, yes. I had nested macro problems yet. I don't think I had. I think the macro is actually this thing that is working nicely. The only problem with my macros right now, kind of, that they are not hygienic right now, and we will need to know to like fix the hygiene of the macros too. But yes, you can define a do while with a custom syntax if you want, but I think it will be in the std anyway. The do while is a pretty common thing, so I think I will add it to the std anyway, just to be more familiar to like the programmers from coming from other languages. Can you define a borrow checker with a syntax rule? Huh? Borrow checker is not a syntax. Borrow checker is like a different thing. Have I ever used a do while? Yes. In fact, in Rust, because we don't have a do while, I need to do a loop, and then inside the loop I do a check and then break, because specifically we do not have a do while. It's not very often that you need it actually, but yes, I think it's a nice thing to have. Can for be used as for each? For is exactly a for each. I do not have a for, like I will not have a for I is 0, and then while I is less than 10, I plus plus. Instead of doing this, you're supposed to write for I in 0 to 10. And this is a for each, basically. A for is a for each. And this is a generator, which can generate numbers from 0 to 10. That's how you're supposed to write it instead. Okay, I have a bug somewhere. I have a bug which says that equal, I probably, right? Zombie Chow. 0 to 10 syntax already implemented? Not yet, not yet. I think I can do it actually though, like right now. The only problem is that I need to like have a trait, something like in Rust, you have an into iterator, and similarly to that, I need to have like something. I call them generators, so I guess I need an into generator for a 0 to 10. 0 to 10 is a syntax for ranges. I can already do that, but then after having a range, I need to convert it into the thing. Gotta hop off. Have a good rest of your day. Thank you very much. Thank you for raid. Zombie Cho. Let me just see what you were working on real quick. A Golang game engine. Nice. We also need a D. Ten. Um. All right. Hold on. Anyway, welcome for the raiders. I'm making a programming language. Yes, you can see it in the castlang.org website over there. I am right now working on introducing tests for all of my examples currently, and I have found a bug while doing so. So I broke something. In my guess a number game, after I guess, it says that the type inference failed. And I think that the problem with the type inference here is the comparison, right? So if I say something like hello is equal to the world, this is going to say false, right? But then if after that I will say int 30, like if I will say 1, which is int 32, is it this one equal to 2? It will say that the equal was inferred to be a comparison of strings, right? And not of integers. This is exactly the problem. What if I do it in the other way? If I try comparing 1 and 2 first, and then I try to do a hello, it is going to be the other way around. So like it based on the first usage of the equal. So that is a problem in the standard library somewhere. Let's see. stdlib equal. Equal is a macro. A left hand side, right hand side. I say underscore as egg, and then I say egg. LHS is this, RHS is this. So egg is like the trait basically for us, where the left hand side is this, right hand side is that. So technically, if I say string, as egg, this is a function that takes the left hand side string, right hand side string, right? What if I say int32 as egg? Then this for some reason breaks. Okay. So I definitely broke it at some point, and I'm wondering when did I break it? Probably not that long ago. Let's see. What if I do egg string, and then if I do egg int 32, this works. Okay. All right. Nice. So what is the difference then if I do string as egg versus string as int 32? No, not string as int 32. String as egg and int 32 as egg. This is doing the inference failure. Okay, well, there you go. More bug hunting today, I guess, instead of implementing new features. Let's see. So it looks like the problem is specifically in the int32 as egg. Let's see. How do I do? The so as means the get impl, right? Get impl somewhere over here. I know that it is a template, and I know that the type as a result is going to be the known type t. We do log info init get for template colon like this. This is what I'm supposed to see. This says yes, and if I do int64, wait, this is actually correct. Wait, what is the problem then? When? While evaluating the get impl, this is when it happens. Template, no, it says it's not implemented. Yes, okay, no, this says that it is not implemented. Okay. This is the correct error right now. I did not implement the equals for this. I only implemented for int32 and strings right now. If I do it for string, then it says while initializing the call, while compiling args into built-in macro call this. While compiling built-in macro call, because this function, which is inside a template, no, it's not even inside a template, no. stdlib. It is specifically over here, this function, args into built-in function equal args, right? This function here was expected to be of a different type for some reason. Maybe it's because of the impl egg for string. This again. While compiling this function, while compiling between macro call, while initializing. Well, wait, while compiling the built-in macro call. No, that's okay. While compiling to this. I think maybe I broke the built-ins. So the built-ins, they're supposed to be like polymorphic and everything. Let's see. So if I do like just maybe the problem is the built-in function print, for example, 1 2 3, right? And then if I say built-in function print but 1 2 3, which is int 32, is this going to yes? So like it is supposed to not work, but for a different reason. Built-in functions are supposed to be polymorphic. Their types are supposed to be figured in the standard library. But because I have tried printing using the built-in function on a string, it was inferred to be a function from string into whatever. And then because of that, I can no longer use the built-in function print using the int 32, even although I would really like to. Off topic, is LED light actually a synonym for stained glass? No idea. Hello Nartilus, how are you? I'm doing great, how are you? I'm making a programming language and I'm having fun with it. I just need to fix a couple bugs. And then it's going to be actually the best language ever. Okay, so the problem is the built-ins. The built-ins. I think actually, you know what? I think I know what I need to do. I think I was thinking about it earlier and then I did not actually do it. The built-in function is not supposed to be a thing. I think we need to have a separate instruction which would be a built-in, you know? So like, so you know, something like I need a special instruction which would be called built-in, you know? And built-in equal, something like this, you know? So this means that the equal is something that is implemented in the backend, in the case for right now, inside the interpreter. Later, when I'm compiling inside the target backend somehow, right? And since I'm going to use the built-in equal here, and I'm going to use the built-in equal here, these two expressions built-in expressions are going to evaluate to two different built-ins technically, I think. You know, a built-in is every time a new thing. And then it is going to be inferred to be a specific thing, because over here we say that ACK is ACK for type T is the one that left hand side is T, right hand side is T, and the function returns a boolean. But when I just see a built-in something, it should evaluate it to something with not yet inferred type, basically. It should be inferable to whatever. And when I evaluate it, I actually like give the built-in function there. Does that make sense? I think it does. So yeah, I think it actually makes a lot of sense to me. So I need a new thing in my so like in the intermediate representation for me right now, what I have is a built-in function, but the built-in function should not even be a part of the intermediate representation. What should be a part of the intermediate representation is a built-in itself. Built-in of just a name string, I think. This is all I need. And the built-in function, this one is going to be removed, I think. So we do this. And then I need to fix a bunch of errors. If I have a built-in then data is supposed to be something of a completely unknown type. So like it should be inferable. It should be inferred. Unknown means that I'm just introducing a new type variable there. Okay, yes. If I have a built-in if I have this show built-in name, this is going to be built-in string dot escaped name. Let's do this. Then if I want the data built in data, there you go. If I want here to evaluate it, so this is where it finally is going to be done. So if I have a built-in of the name, this is where I should just find. So like a built-in is a value basically, right? I'm going to construct a new value. This is basically going to be like functions or potentially also like something else. Some things, right? So do I just do built-ins dot, and built-ins is a thing that is described later. Oh my god, this is actually very annoying. Because the built-ins are specified later. So the built-ins is another recursive module then. No? Say built-ins dot get name. Built-ins is unbound module though, obviously. So I have a module built-ins. This is specified over here. But let's move this module out. Let's move it over here in my list of recursive modules. And built-ins is struct. Built-in get name, yes. And this is going to be a just value of that stuff. You are built-in? Hello, Ray March. How are you doing? This requires recursive modules require an explicit module type. Built-ins is built-ins T. Sure. Built-ins T. Let's go here. Module type built-ins T is sig, and I mean technically all I need is something like get is a function of string into interpreter dot value, right? Which means that it should be specified after the interpreter signature. The module interpreter is an alias for this, which is the current compilation unit. Wait, what? This is the module type. Oh, I cannot specify it for the module types. Built-in st. Built-in st must be a functor then, right? Can I do this to be a functor based on the I, which is the interpreter? Is this how I do it? Syntax error. Back at code and implementing data layout validation for shame. All right. I am having a skill issue with OCaml right now. Syntax error. Maybe I do something like value, so built-ins. What is a value? Maybe type value is like over here. The expression is type built-ins value, but an expression was expressed of type value, of course. Okay, let's see. What is my built-ins? Built-ins is built-ins with signature constrained by with has no component named underscore. With value being equal to the impl.value. No. How do I do this again? Where's my checker? With type, of course. It's with type. Let's do also the brackets here. This with type value being that. All right. Signature mismatch. The type value is required. Okay. Type value is equal to impl.value. Are you happy now? Signature mismatch. Module get is required but not provided. Okay, that I can understand. That is something that I can understand. So if I initialize all of my built-ins, oh, I have a lot of them. I have a lot of them here. So this is the this is the all, right? So I say something like that. Get name is a string map dot find name in all, right? Is that it? And then built-in macro. Shit. Can I open the other thing here? Why is OCaml has to be so annoying? Can I just open impl here? Unbound module built-ins.all. Yes. Yes. Val all is value string map.t. Of course. What about now? Unbound constructor built-in macro, but built-in macro is a part of the impl. Unbound type constructor built-in macro. Yes. What if I say impl dot built-in macro? It says unbound type constructor because the value is specified in the signature. And yeah, okay. So like if I want to use something like that, then I need to have it in the signature. Okay. Understood. Let's go to the impl then. So I need to have the type built-in macro, right? But it's built-in macro. I don't know that this is what it is, right? Also foam. They just make me want to write everything in one module, this OCaml language. How do I make something actually split properly instead of having one file with what do we have right now? Already almost 4,000 lines in one file. How to split it correctly? No idea. Can I specify what a built-in macro is in the signature? This only says the type. This, like, can I say type is equal to, like, the thing? You know, name is string. Can I do this in the signature? I guess I can. Okay. All right. Sure. So I just, like, I just need to duplicate my type definitions everywhere. Is so they want me to copy paste everything everywhere? That's what they want me to do? Anyone knows OCaml in chat? What is this? Unbound constructor ast.t. Type ast. St string map t into new bindings boolean into this, and then I have type this, right? Okay. Show something your lang produced Solform. Solform is also making a language. Is that so? Signature mismatch. Type declarations do not match. Type built-in macro. Name string impl ast into this, into the expanded macro. Is not included. And type built-in ir. Yes, because it was supposed to be expanded macro. Expanded macro is compiled or a pattern. Okay, sure. Like, I just need to copy paste everything, it seems, right now. Expanded macro. And I have type expanded macro. Okay. Unbound value, expand AST, because now I need to know how to expand AST, right? Yes, so I need to have val expand AST. And this is going to be AST. It's going to be state AST into expanded macro, right? Or something. It was supposed to also have the new bindings there. New bindings. Boolean. What is the language that Solform is making about? Is it also a shading language? Value to type. Unbound. Okay. Value. Value to type is a thing which takes a value and returns a value type. Okay. Next. Unbound value. Eval AST. Eval AST is equal to state into AST into value into evaled, I guess, right? And then I need to know what and the evaled is. Type evaled, right? Unbound record field, because value to type Wait, value type eval ist.value, because eval is a thing where we have a value of type value. And then we also have the new bindings, which is what? Signature mismatch. Value. What is this error message? Extra field, new bindings is provided in the first declaration. Eval is new bindings is a local string map. Okay, there you go. New bindings is a local string map .t, which means that I need to know what the fuck is local now. Type local. Okay, what else? Compiled. This means that I actually need to know what expanded macro is. I need to say that this is compiled of. And if it is compiled, then it should be compiled, right? Or it is a pattern of a pattern. So I need to know what a compiled and what a pattern is. Compiled. A pattern. OCaml, you approve? Do you know how to write code properly in OCaml? Right now I need to copy paste everything into the module signature and then copy paste it again in order to like just have different modules. Instead of writing, like, I don't know, I feel like the easiest way to write OCaml is writing everything in one module. Otherwise, it's so annoying. It's like the most annoying thing ever that I have seen so far. But maybe I'm just having a skill issue. So now I need to know what this thing is. Okay, sure. Data. You want to write everything in a module? I want to write everything, like my program is highly recursive. So because of that, I cannot easily split things into multiple modules because then I need my modules to be recursive. In order to have recursive modules in OCaml, you need to provide signatures, which leads to a lot of copy pasta, as far as I see here. And like, yeah. That's why I want to write everything in a single module, because it will make my highly recursive program to be easier to write. Am I supposed to do something else here? You think it's easier to write recursive stuff in a single file? Yes, exactly. That's exactly what I'm saying. And that's really bad. Because it means that my entire program is going to be 100,000 lines of code all in one file. This is horrible. This is horrible. File systems are overrated. Okay, maybe it's just me. Yeah. But like, it's also really annoying because I cannot like group things. So like, I have like the things that are like recursive, and I cannot group them by the by the logic, right? Because you have first a bunch of recursive type definitions. You cannot mix and match recursive types with recursive functions, because you have separate things, which is like type something and some other type and some other type, and then you have separately a let rec one function and some other function and some other function. This makes it like that I need to like first recursively define all the types, then recursively define all the functions. And is there anything else other than types and the functions? Yeah, also like there are constants, and constants cannot be recursive if they're not functions. I don't know. It's like OCaml is only simple if you write like a small program, I feel like. Otherwise, I don't know. I mean, as far as I understand right now, maybe I'm wrong. I think I'm supposed to not use recursive modules. Recursive modules are cursed, completely cursed, I think. What I want to do here is to do a dependency being recursive, I think. The end function is probably hard to split. However, the logic with the end functions we split it. Never used rec modules, but have you used functors then? Hello, Athena. Have you used functors? Because like I said, my entire program is very highly recursive. I have an interpreter and I have a compiler. Compiler might invoke an interpreter. Interpreter might invoke a compiler. I cannot just split them into like being like one being dependent on the other. I need them to be recursive. I think what I'm supposed to do in OCaml is something like this. I would need to have a module interpreter which depends on the compiler, and compiler is like compiler, you know, and this something. So this is a functor, you know, and the something. You never had a need for them, you did not use them. Okay, how big of a program have you written in OCaml then? I'm not, I mean, I can't say that I am Hello World. I mean, Hello World is pretty easy and nice to write in OCaml, yes. Okay, you have a database. So like I don't know, I have not tried to make my own database, but maybe when like so like your program on the other hand is not highly recursive and you can easily split them into different modules, right? Let's see. You have, where's the source anyway? Dune project. You have where's the modules? Is it in the silo maybe? You have a lib. You have only one single ML file. Okay, this is tiny. When it's tiny like that, I can see how it's easy. dbcaml. I guess this is the actual one. You only you have like these things. Okay, let's see how big they are. Driver. This one is tiny. This one is tiny. This one is tiny. This one is also tiny. Okay. But you do split them into separate modules instead of writing them in the one file because it seems like they are not that recursive, right? So in order to know what the connection type is and in order to make a connection, you need a query though for that, right? So what is a query? C, query, colon. It's just a function. Okay, query is just a function with a bunch of named arguments. Okay. Like you just don't have like recursive stuff in your program, I guess. Using database toolkit built on Riot and actual model multi-core scheduler. DB camel driver Postgres is the biggest module. Okay, this one has a lot more stuff in it indeed. How do I see the biggest thing here? These are the messages. Escape SQL value. Buffer create, encode param. Find. Buffer tools. Yeah, so like you do not use functors, you do not have recursive modules. Like I don't understand how to write my program without it being recursive though. Like I said, I have an interpreter which is supposed to invoke a compiler, and I have a compiler which is supposed to have a comp time like in Zig, so I need them to be recursive, right? I don't understand how to do this. I think it depends on the type of a program that you're writing, and for this specific program, you don't need that, but I need, and it's very annoying. But let me see what I like understand. I think. What do I need to do? Maybe I'm wrong, but maybe. Let's see. I will have a module type. Interpreter. Interpreter type specifically, which is this is a module type. An interpreter depends on the compiler, right? So I will have the compiler, which would be a compiler key, right? And this is something something. Let's see. This is okay, and the module types cannot be functors, right? Can we? Or camel module type functor. Can this not be a functor? Is a functor only like a specific module? Parameterizing modules with functors. Like, can I not parameterize the module type with a functor? Because like also like when I do this, there is this thing where I use the with keyword when I'm specifying like, for example, I have the inference checker, right? And then I would need to like, I don't know, it's so annoying. I need to do this this thing where my inference is a specific inference. I think this is the only one that I actually extracted successfully into a single file. So I have the inference system, right? The inference system that is like doing a bunch of things. I have like the signature of it here, and the inference module is not a single module because the inference is also dependent on the inference checker to like check if my stuff was inferred correctly. While the inference checker is going to work, I potentially want to make some more inference progress. So actually, maybe I just need to do the same thing. So instead of it having being a module, it is a functor which has a dependency in the form of the module argument, right? Which makes it a functor. And then whenever I infer that two like inference variables are the same, I am invoking the checker function. Is this the similar way of how I'm supposed to like also make the compiler and interpreter? Am I part of the Caravan Discord? Nah, not. It reminds you of the problem you are having, but it's different. I mean, technically, like, let's say that I was writing Rust, right? In Rust, it's just easier to split your, like, so in OCaml, a single module is the same as in Rust, a crate. A crate can consist of multiple files. Crates can be, like, pretty huge, and, like, you can recursively use anything within a crate really easily that way. In OCaml, the unit of compilation, basically, is the single file, which is a single module. So in order to have like let's say that in Rust I would want to split a crate into multiple crates, right? Which would be like the interpreter and the compiler separately. What would I do then? I would say that the interpreter is what? I would probably do the same as I was doing here. I would make it a generic thing which takes as an argument the compiler. This would be working with using traits. The module types are basically the traits here. So I guess this is the correct solution actually. Some OCaml devs there that can help me. No, I think I understand the correct solution here. I'm supposed to use the functors, not recursive modules. You would say the interpreter is not dependent on the compiler, or you will have a trait which, like, you cannot make the interpreter not dependent on the compiler because the interpreter needs to have a compilation inside of it. Because the interpreter might while interpreting, you see like a new like something, and you need to compile it before interpreting. You know, because of the comp time. If I did not have the this idea of having the comp time like in Zig, then you can compile first into the like intermediate representation, right? Intermediate representation is like its own thing, and then I'm interpreting that. And so like the compiler knows about like what the intermediate representation is looking like. The interpreter knows what it's looking like, but the interpreter is not dependent on the compiler, and the compiler is not dependent on the interpreter. But since I have the comp time, all of them are like dependent on each other. So I think in Rust I would probably not split the crate until I really need to. So I guess I don't know. I feel like it means that for this that yes, in OCaml I also need to not split my file into multiple files and write everything in one file, or use these functors, right? So let's say that like I don't know. I think it's like similar to how you can have like multiple, for example, rendering backends. Let's say that you are making a library which is called like WGPU, right? I have not seen into their source codes, right? But you have a WGPU and it has multiple backends, right? So how are you able to write multiple backend, right? You have a trait for a backend or something like that, right? So trait is like a module signature would be in OCaml. And then you make your actual like thing to be dependent on that. Same as I'm doing here, I think. I'm interpreting comp times before compiling the rest of the problems. The difference is that you are interpreting after compilation. In order to interpret something, I need to compile it, yes, because I'm interpreting the intermediate representation, which is being compiled. I'm not interpreting the AST directly. I am first converting the AST into a compiled program and then interpret the compiled program. This is what you are doing here, driver. Module type, this, yes. So you have a int f, whatever that means. An int, which is a floating point number at the same time, potentially. You have a config, you have a state, you have a connect, which is a function from a config into a connection. What is this symbol here? What is an opening square bracket into a more than? It's like a pipe. And then you have a quotes here. I think I've seen that. Is that in the std, or is it part of the write maybe? Part of the write. Is write like one of the stds? I'm using the OCaml like standard library only, basically, right now. And you open a logger make. I mean, that makes sense. Okay. So when you're using the inft then driver is a module inft type t is driver is module inft with type config. Wait, hold on. Can you treat modules as actual types here and as values? With type config is underscore and type state is underscore. Does it mean that the underscore is supposed to infer what it actually is? Right, is a runtime like Tokyo. Okay. Driver is module Postgres. So you can treat modules as actual values, right? Okay. But how does this work if it has like a type inside? Like it has type state there. Like I guess if you never like if you only access the connect from there, this is like a didn't trait kind of thing from what I understand. Then create an interface which returns back at a camel driver db camel driver t that be used to create a connection to make queries. Right, because like if you have this module as a value, then can you access the type, or can you only access the functions from it? What if I try the functions only? Okay, so I understand it correctly then. Okay. You can only like access the types if you like have the module from the outside, not as a value. Right, okay. But yeah, okay. Makes sense. Okay. Do I need to like refactor my entire program then today? Do something like this. So like I said, I'm already doing this in my type inference. My inference is split into a separate module, which depends on the inference checker. Inference checker is basically a thing which knows how to unite two values which were known to be equal and knows how to show them, to show errors, I guess, right? So inside here, I say that my checker is the infer checker, which is like checking the values, because that's what I'm inferring, and then I'm doing this here. Yes, okay. Okay, what does the with keyword actually do? Can I construct this thing without copy pasting? I mean, I know that over here I only have two methods, which is not that bad. I don't know. It's too hard. It's too hard. It's like it's 1,000 times harder than the Rust's lifetimes and Rust's async to me right now. I cannot figure it out yet. Rust's lifetimes is like the the most obvious thing ever. Okay, hold on. So yes, I have the interpreter. Data. This. God, oh my god. I hate my life right now. Can I have let rec function is like something, and then I want to have and module. Like I cannot do this, right? If I yes. So like the problem is that I am trying to like group some functions inside a module right now. So I need to like get those things out instead right now and just like make one huge module something. Like I want to like do it the correct way, but now I cannot decide what I'm doing. A huge pile of spaghetti, or splitting it into modules with dependencies making everything a functor, which will take a year to do. What should I do? Did I do anything like... I started to like make the built-ins, right? Okay. Other than that, I did not do anything useful. So I can like discard all of that, commit like my tests that are failing, and then slowly try figuring out the correct structure. Maybe. So I want to make built-in a new thing. And that would depend. Okay. Yes, I moved the module built-in. Discard everything. I think I discard everything. I first want to commit this thing. So I like some of my tests are working, right? Okay. Colon, and this stuff. Yes, okay. Next flake check. Okay, there is one test that is not working, which is the Fibonacci is not working because built-in is not found in the current scope. So I actually need to... Let's do lib built-in this over here, right? I need this still to be built-in function equal, right? This is not working because since I'm using the same function, it is messing up the type checking. Okay. Next flake check. This is just going to fail this because of the type checking. Yes. Okay. Good. Good. Improve tests. But even though I have a failing test. Okay. Let's try doing it the correct way. It's going to take a lot of time. I don't know. Can I do it in one day? We'll see. I don't know. Maybe I can do it fast somehow. But we want to split this entire file, which is 4,000 lines of code, into separate modules, right? That are going to be easier to understand. For example, this is my interpreter. What an interpreter is, right? Okay. Let's try doing this somehow differently. Can I just rename the files and start like from scratch or something? Can I move lib slash interpreter into lib slash interpreter old? Can I do this? Interpreter old corresponds to an invalid module name. You cannot have a dash in your names. Okay. You cannot have dash in your names. So we move the interpreter old into lib slash interpreter underscore old. This is going to be okay. Kind of. The main is the one that is probably not working here, because now this should be interpreter old. Interpreter old. On the do you have also problems with the language server, Privan? Because my language server is very constantly breaking. When I try to go to the definition, it throws an exception. If I try to rename something, it only renames it in the single place, not everywhere it actually being used. Is that normal? OCaml language server behavior? No, it's just okay, because I didn't. Okay, sure. Sure. Let's do this. Let's do this. How about I push? Let's try doing this completely in a new branch. Git check out the new branch. Refactor. Sure, let's do this. Then I say over here, interpreter into interpreter old, because the interpreter is a huge module that contains everything right now. So let's do something different. Let's do something different. So I need to create a new file. This is going to be specifically the lib interpreter.ml, right? Interpreter.ml. This is going to be a module which is interpreter. Since this one is going to have a dependency, I need to not write stuff immediately here. I will need to have a module make inside. Module make is going to depend on the compiler, right? If I have like ML files and then MLI files, right? Can I have the ML interface as a type somehow, somewhere? So if I say over here, module make compiler, struct end, right? Obviously the compiler right now is not defined, right? But compiler, maybe I will like have compiler.t, what's t, the capital T, because that's what we are going to make in the end, kind of. And then I will have a new thing which is going to be called lib/compiler.ml compiler. So I will have module type T is equal to the signature. So this is the signature of my thing, right? And then I will have a module in the compiler in order to it depend on the interpreter. I'll have module make interpreter. Right? So like the compiler depends on the interpreters, just like the interpreter depends on the compiler. So this is an interpreter dot t. It's just literally the same stuff. Struct end. Can I make it this way? So interpreter over here will also have the module type t, which is the signature. Something, right? So I can do it this way. Okay, if I go into main, how about, or like not into the main, like I need to like have the main thing, you know, like the main thing of the library, which is like making everything work together, you know. What if I make this morning ICS boys morning? What if I make this lib/kast? Like this is the main thing, right? Kast.ml. This is going to say that module interpreter is equal to the interpreter.
Bit of fortune.
Thank you. This is going to be interpreter dot make compiler, you know, where, so like this is where the recursive modules are actually going to appear. I go and say module rec is this interpreter, and this is colon interpreter dot t, right? Illegal recursive. Okay, so I need to have different names because this is a recursive thing. Okay. So the interpreter. This is the interpreter F. ft. Okay, sure. Let's have this interpreter F. I'm going to move lib interpreter into lib interpreter F ml, right? I'm going to move lib compiler into lib compiler F. Okay, is this how I'm supposed to do this? Interpreter F compiler F. The interpreter, this is based on the compiler F, and compiler F is based on the interpreter F, right? This is cast interpreter F, which is missing. Yes, of course. Cycle error. What do you mean cycle error? Fail to find open path. This is a directory. What do you mean? What do you mean cycle error? It was literally working before. Cast.ml. Is it because okay, let's just comment this. It says this failed to screen. Let's see what we say here. We have a dependency cycle between compiler and interpreter. Yes, but it was literally compiling before. What is different? I just like if I restart this. So hold on. Yes, I restart the Dune and it works again. Amazing. Amazing. Why would it work like without me restarting this? That would be yeah. Okay. Interpreter. No, hold on. The module is alias, which is missing. Or is this the same error still? Cycle error still. Okay. Why do I have a cycle error? Compiler F is an alias for this, which is missing. Yes, because these are recursive. Okay, actually, I cannot even make them recursive, right? Because how do I even specify this thing? Well, I guess because this needs to be in a different thing. Can I have a module compiler T, unbound module type compiler T? Like, can I, for example, have a file which is going to be saved as lib slash compiler t.mli, right? Because this is an interface, right? No config found. Try building, Dune build. Is it because I like it's not a module? Can I not have an MLI file without the ML file? Okay, how about then? How about then I create something like lib slash modules.ml. How about this? How about this? If I have modules.ml and I will have something like module type interpreter is a signature end, right? Can I do this? No stuff found. Okay. All right. Let's remove lib slash compiler t.mli, right? Modules. Okay, this looks like it's happy now. Unbound module compiler t. So instead of saying the compiler t, I will say modules dot compiler, right? Modules needs to have an interpreter and it needs to have a compiler. So this is where I specify the signatures. Compiler is this. This is that. Instead of saying interpreter old. Unbound module interpreter old. Why is it unbound? If it's literally still in the same file. List lib. I have an interpreter old. Why is it unbound? Interpreter module. Interpreter old. Unbound. Why is it unbound? Let's try restarting. If I restart it, what's going to happen then? It's nice that I cannot scroll here. Okay. It says unbound interpreter old. Okay, why is it unbound? Module. Interpreter. Can I say something like kast dot kast is this? Okay, yes, sure. But why can I open the kast, but why can I not open the interpreter old? No CMI filed. What is a CMI filed? This is actually does not. Okay, this does not introduce an error. A is an alias for module interpreter old, which is missing. But it does not show me an error here. Okay, because I can bind modules to something that doesn't exist. Amazing. Very nice language. What happens? Bound module. Interpreter empty. Because this is unbound module interpreter old. Why would it be unbound? It literally is there. I literally have interpreter old. This is the thing. Let's go into the kast. Oh, I do open kast. Wait, why do I open kast? Is this what was there before? Lazy git in the main. No. Wait, hold on. I was opening kast before. Oh, I see. Because it is like kast. Yeah, okay. Because I have a kast inside kast. Kast is a library, which is like a multiple module, right? And then I have like this thing. So maybe the kast.ml should be named something else then, or something. Is this the problem? No idea. What if I do not open it? What if I don't open it? Then the interpreter old is unbound module still, right? So but can I do kast dot unbound module kast? Okay. Opening kast does not even do anything. Kast dot interpreter old. Okay, so let's go here and let's say module interpreter old is interpreter old. Can I do this? And this is the interpreter old. Okay, this works for some reason. So is it because I okay, so maybe the reason it works is because if I have maybe the reason it works is because if I have the module with the same name as a library that I'm making, then that's the module. Otherwise, the root module is auto-generated. Is that how it works? Tune module same name as library. I think that's what's happening here, right? Using the same name for library and its main module without breaking auto wrapping. I'm writing a library that represents the data structure. Is this how it works? There's something then in Germany. Elemental magic. How's your game progressing? Okay. I will try to suffer through this today. If I will not be able to do this, then I will. Then I also am considering rage quitting OCaml completely and rewriting it in something else. I don't know. I don't want to do that though, because that's a lot of code that I have written already. Okay. Well, okay. So this is the interpreter old. Okay, that works. Okay, nice, nice, nice. Interpreter. Okay, so I want to have these things. Interpreter F. Okay, so there you go, there you go. Now, inside over here, inside the cast, right? I want to have recursive modules now. So because the actual interpreter still refactoring in order to use lenses normally in Haskell or wrapping them in refires, you need the predictive types, which breaks all type inference. So I've been adding type annotations for many hours. Nice. Amazing. Amazing. How do you like the module system in Haskell though? Because in Haskell, isn't it the same thing? You can like a single file would be a single module, right? And that's like, and you cannot like, can you have recursive modules then in Haskell? So if you have something that is recursive, you still need to write everything in one file. Is that so? Or you solve it using what? There. Okay, so we have interpreter and compiler. Compiler is compiler f.t. No, it's not this actually. Hold on, this is not that. This is going to be equal to modules.interpreter, right? And this is going to be of type modules.compiler, which is compiler f.make interpreter, right? Is this the good thing? Okay. If you have mutually recursive data types and you believe you need to put them all in one file, at least this is what you have done. Okay, yeah. Isn't that annoying though? I mean, yeah. Nobody has claimed third. I am the third. There you go. Okay, so is this the correct way to do the OCaml then? So I have the, so I would have the modules that are supposed to be recursive as functors instead. And these things, module make, is having a dependency in the form of the functor argument. I will, as a result, get the module.interpreter. Modules.interpreter. So if I know what the compiler is, then I can construct the interpreter. If I know what an interpreter is, then I can construct a compiler. So for that, I need a special module which defines the types of my modules. And then I need a root module which is bringing them all back together by making them recursive. Is that a good way that I'm doing it here? Your solution is to deal with this, to separate functions from data types. Languages with object system like to insist functions and data types go together, but I think it's a bad idea. With only data types in a module, having a lot of them is okay, because Haskell data type definitions tend to be short, with only data types in a module rather. Yeah, I guess I can extract the modules separately. OCaml has objects, but I'm not using them. I'm doing it the same way as in Haskell. In Rust also, you split the data from the definitions. So like, yes, kind of the same thing, I guess. Modules compiler. Okay. So let's see now if I have an interpreter F. An interpreter is something. So I know what is the interpreter value, right? Let's just write down the signatures maybe. I mean, I cannot write the signatures without writing the definition too, right? So I will need. Okay, let's go to the interpreter old, right? This is what I'm trying to untangle here, right? What is the interpreter? These are the things that the interpreter should be able to do, right? These are the things that an interpreter should be able to do. It should be able to have a value. It should be able to know what a type of a value is. Interpreter is something that has a state. We need to be able to construct the empty state, right? We need to be able. So the inference unite. This is the thing that goes into the compiler, I guess. So the compiler needs to know what the what are the values too. The compiler also has a value. The compiler value is the same as the interpreter value, but how do I write this here? Because the compiler is interpreting the same values that the interpreter is using. Basically, the modules for the data types in your project and the functions in your project both format directed as cyclic graph. Then functions can freely import whatever they want from the data types module. This has been good enough for you practically. I've tried using the type class system to mimic something like the OCaml functor system, but found it was easier dealing with all concrete types. Yes, I agree. But the functions also can be recursive, right? So the modules for the data, so you have separately the modules specifying the types, and then so like over here, for example, right, I am already doing this differently than you are doing, right? I'm grouping the types and the functions in the same module, right? But you want me to do this as a part of the thing, a separate thing, right? So like the interpreter types, so like we want to separately have the types, and we want to separately have the functions then, right? So like when I'm defining the functions, they would work on the concrete types instead of all of this, because like I would need to say for the OCaml, I need to tell the OCaml that this value and this value are now the same, because otherwise it's going to like be angry at me, right? Okay, I think okay, survival, hello. I think I agree with you. Let's try this. So like this, I'm going to then rename this. Okay, maybe like we have a modules, and I will also have a new file which is called types. Types. How about that? All the types that I ever will use in my entire program. So then the types can like maybe I will like split them into smaller modules to form a DAG. Yes, but what am I making? Another compiler or what? I'm making the same compiler. I'm just like trying to refactor my code so it's easier to work with, you know? So let's try writing this as something like lib/types.ml, right? Can I do this? So once again, instead of having value type state, right? Let's say that that type value is something, right? So what is the value? I guess we just bring it specifically from here, right? Hold on, maybe I just like do the entire like this thing. These are all my types. Let's just move them all into the types module. So these are all my types that I'm currently using inside of my interpreter. Let's see what we have here. We have a value. We have a value type. We have an inference variable. We have a type variable map. Type var map. Yes, because I need the concrete things here, of course. Sure. Okay. I think I like this idea. Okay. Making the first compiler for the kast language. No, I'm not making the compiler yet. I mean, we have a compiler. Compiler is compiling to the intermediate representation, which is being interpreted. I don't have like the actual compiler, which is compiling to the native code yet. Oh shit, this is going to be a lot of work. This is going to be a lot of work. interpreter old. Let's see, and then I have the ID, right? Do I just open it or what? Where do I get the ID from? Yeah, I just say that ID is this, IST is this. So like ID is at least like in its own separate module. Let's see, types. So I say that type ID is equal to ID.t, right? That's what I say. And then AST is AST dot node with data, which is AST data is just having a span, right? So type AST data is span, which is span dot, what was it again? Span dot span, which probably should be renamed to, as everything else in OCaml, to span dot t then, right? I'm scared to rename it though, because the language server is actually not very good at renaming stuff. Okay, so we have AST is node with attached AST data, right? That's what I want. The string map. I will open the prelude here. This is my own prelude. Okay, then inference. Okay, so inference then is going to be the same. Inference, like I said, is the one of the only things that is actually like split here into its own thing. So how about so instead of having a functor, we want to just like deal with concrete types here, right? But okay, I mean I can make the types. How would we go with the functions being recursive then though? For the functions to be recursive, I still need to be a function which would like specify this thing, no? Because the inference needs to know how to do the type checking. That when I infer that two variables are the same, I need to check it. This depends on the I mean, I can make that directly in the inference, since I would know the concrete types now. Maybe I would be able to do that here directly. So I just move those functions into the inference checker. Okay. Hmm. The files kast.cmi and kast.cmi make inconsistent assumptions over interface kast. Amazing. What does that even mean? Kast underscore underscore and kast are doing different assumptions over the interface kast. Okay, so I guess it's because over here, right? It's because of these errors actually. So this is missing the type value, right? Because okay, but the module compiler should not have the types now. It should only know about the things, right? So I will open the types here then instead, right? So types is a thing that describes all the types in my entire project. This is an alias for module kast types, which is missing, isn't it? Directly over here. Okay, it's because of the inference variables. Okay, so the inference variable. Okay, is the only thing that is missing here. Inference variable. So we go into the inference, and this is my variable. But like at the same time, if I have all the types being concrete, defined somewhere else, then I cannot hide the thing which is like an implementation detail. I cannot hide the fields of my data structure. That's what like these signatures are supposed to give me, right? So like I can accidentally like access the data that I'm not supposed to, because it's supposed to be only like it's supposed to be like only used from within like this module. You know what I mean? So like I know that the type exists, but I should not know the details about the type, actually. In anywhere except for the inference algorithm. Exactly, you think you should know the details about the type. But if you know the details about every type, then it means that you can easily construct the type with the like you're supposed to make incorrect data representable, right? How do you do this? If you know all the details about your type, you like then you can just construct a value of this type yourself without the like the like without going through the function you are supposed to go through in order to like correctly set up the data type. It means that anyone can like mess with my type inference algorithm here in some other module than the type inference. It should be hard to do the that thing that you are not supposed to be able to do. So you need to hide the details about your type. You want to use parametricity to rule out bad code. Makes sense. You don't disagree with this, but you have seen bad examples of hiding implementation details where it became harder to do the correct thing as well. How hard would it be if I actually had the types directly here, though? Is that going to be hard? Like I know that the type value exists, but I do not know the specific details about it here. Although technically, the compiler, in order to in order to implement this function, needs to know all the details of a value. So like these specific ones, for example, I should be able to know about the details of them. So I think this. So I think it should be like a mix, basically, of both approaches. For some things you want them to be known. For some things you don't want them to be known. So like the value and value type, for example, are the things that are used everywhere. But the interpreter state, should the compiler know about the interpreter state? I don't know. I don't know. Interesting. Let's try different things. Open types. Okay, and then the types need this inference stuff, like I said, right? So we want this infer variable of the inference variable. I think a mix makes sense. The rule of thumb is you want to hide what you need to prevent the outside world from constructing an invalid state, but otherwise be fully transparent. Yeah. Dun, dun. Okay, so how does the inference supposed to be working then? Let me see here. So like I said, the inference right now over here for me is this thing, right? Is this thing. I guess the module type T is similar to the compiler. So like this is the inference functor. The inference functor that needs to be made using the checker. With type inferred is checker T. Okay. So inferred, what are we inferring? So like I, for example, know that things that I'm going to be inferring are the values. So this can be like kind of simplified. Don't expose caching details, for instance, is an example. Yeah. That's one thing. That's one of the things that I actually have, right? I have a cached template type. This should not be exposed from the to the outside of the thing that actually like makes the caching, right? I do the push-ups. Done. So what should be the inference? Instead of having the module type T, I will, like I said, these are the module types. I'm right now going to try doing this. I'm going to have the modules module. This is specifying all the types of all the different module types, right? So I have a checker, and I have this is the inference, right? The inference inferred is supposed to be a value. This is supposed to be a value. Value. And checker is also the one that is checking the values and merges them together, I guess. Show value into the string. Module type, compiler, inference unite. This is like part of the checker too. So the compiler is the one that is knowing how to like unite. This is like the same thing. So should it be specified twice? Different things also, since my types now are going to use the variables. This variable is actually not known what exactly it is. I don't know. What if I start first by like exposing all the details? Like expose all the details, including the caching details, right? Because that's the easiest way of doing this, just having all the things, right? Having all the things over here. This is my inference types. Let's see. Inference data, checks, value into bool, inferred, value option. Mutable type var is a var option, and the var is mutable data of that. So type inference data is somewhere over here. And can I do an end here? And I can rename this Enter not var data, but inference var data, and this is inference var then, right? And then we have other inference var. So this is just specifically inference var. Inference var is that. Okay, nice. I do not have any more problems in this specific. So this is all the I think this is all the types that I have. So in order to define all of my types, it is only 200 lines, right? Not that bad. Although, I don't know, I still feel a little bit bad about the fact that like the inference data is leaked here basically. The state, this is the state of the interpreter only, right? The compiled stuff, evaluated stuff, I don't know. To do GADT. Did I want to do a GADT for the expanded macro? Anyway, let's not think about that. Compiler F. So the compiler, once again, what is the compiler? We have the inference unite, right? Inference unite. So let's go into the interpreter old, right? And I want to have inference unite. So I have a bunch of things here. Inference unite types, inference unite. Wait, can I just go into the V? This is the thing that I want to unite. So we delete this from here and I go into the compiler. Compiler is the one. I mean, actually, you know what? I think that this then should be inside the inference. In this case, it should not even be part of the compiler. This is part of the inference algorithm. Although I want to do like be the inference completely like independent. I don't know, whatever. Let's have this to be my inference. Sure. So inference knows how to unite things, which means that the checker dependency is actually not here. I do not need a checker. I will still have a make in case I want to have some dependencies here, because like in the future, if I want to like have some dependencies, right, then I do this. So like everything is going to be a functor because of that, right? So this is going to be modules.inference. There we go. Type inferred. I do not need that. I do not need that. Var is required but not provided. Modules inference. I do not have types anywhere. I do not have this anywhere. Open types. Var. 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 Var is the same as inference var specifically, right? Okay, there you go. There you go. Okay, so inference unite. I do not have that. This is part of the inference algorithm. So for the inference algorithm, and to be able to add checks, and to be able to show the ID of the variable, I need to be able to get the ID. I need to be able to set the variable to be equal to the value. I need to make two variables same. I need to be able to construct new variables, and to get the type of the inference variable, I need to get the inferred value if it is there. And then I also need to have the thing that is called unite. Or I guess like technically this is an implementation detail now. I actually do not even need that. Checker is also not needed. Okay, let's see. Empty state eval show. So like what is showing values part of the interpreter, or is showing the values part of something else? I do not need to. I don't know. I feel like maybe I will have the module show. Can I, like, does that make sense to, so that like if all of my types are like defined in its own module, in order to like be able to show these types, is me showing the types part of the types module, or parts of the show module? What would that be? I don't know. Let's do sig end. So I need to be able to show this, and I need to be able to show that, right? Maybe this is the way to do it. Discard value. This is also an implementation detail, I think. Eval file. So yeah, I need to be able to evaluate a string, or I need to be able to evaluate a file. This is like the file name, right? File name is string. Type of value. Type of value is, I think this is part of the compiler because of this ensure argument. This might be like ensure that I compile something right now. So yeah, later I want it to be a little different, I think. Show ID. Okay, next. We have a compiler. Type of value. Okay, let's go into the interpreter old. Let's see over here the thing that is called. You think abstractions involving hiding types make sense if you're doing something actually fundamentally abstract, like the abstractness in controls lens, for instance. You don't like when concrete things that are not abstract nevertheless hide their types if they are. I see what you mean. Yes, like abstract, like premature abstraction is evil, like premature optimizations, I guess. I can kind of like, yes. Like right now we're not doing it being abstract. No need to create the abstraction before we actually need the abstraction to be an abstraction, right? I want to find here the thing that is called a value type. A value type and value type. This is just the types. I already moved all the types, right? Let's remove this from here. Let's remove this from here. When something says it's general abstract, when it is in fact only one specific thing, all you've really done is prevent yourself from being able to solve your specific problem, because you later learn it's isn't actually as general universal as you hoped. Yes. Yes. I agree with that. But yes, what I'm solving is I'm not trying to abstract things. I'm just trying to make things live in their own separate modules, because maintaining a single 1,000 like 10,000 lines of code file is going to become really hard. I really like, I don't know, I feel like all I'm missing is just like being able to split a module into multiple files, because of the core thing where each file is its own module, which should not be the case. I think you should be able to write a single module in multiple files. So that I can go between things. You like radically small modules. Yes, but like you cannot always do that. Like because of the high, like you can do this only if it does not have like recursive stuffs, right? Over here, I have a module type ID. Can I have this be in its own module? New. Can I have this be its own module? lib/type ID. Like if I open the types here, should I be able to just have everything here? And I guess the prelude. And then I have the inference. Okay, it does depend on the inference here. Type ID needs to know if the value is inferred or not. Okay. So I will still say module make color modules dot destruct this modules dot type ID. But yeah, you understand my pain though, right? Because like I said, my entire like compiler slash interpreter thing is very highly recursive. So which is why I cannot make a ridiculously small modules like you like. It is really hard to do so. Module type ID. Type ID is the one. Can I move a file? Move. Move the current buffer and corresponding file to a different path. Yes. Nice. Move into type ID F. Type ID F. Yes, exactly. That's what I want. F. Modules. Inference. Now we have the server. Now we have the protocol error, server error. Okay, nice. Module type ID. Everything. Okay. Camel. Type ID. How does my language work? Will it be converted to assembly after compilation? As an, like, optionally, yes. But I don't have it yet. It is supposed to be both interpreted and compiled. I should be able to convert it to assembly. I should be able to convert it to JavaScript instead of assembly too, which is probably going to happen before assembly, so that I can target multiple things. Both how? Well, by compiling into different targets. You know how, for example, like C already can be compiled into a JavaScript or into assembly. That already can happen even in C. Your functions are highly recursive and your data types are highly recursive, but your data types should depend on your functions. Yes. So you should be able to create modules of only functions. Yes. You can use helper functions to split those further. Yes, potentially. But will be probably any pain anyway. Yes, probably pain anyway. Probably a pain anyway. Exactly. Any plans on a Gleam stream? Nah, I don't think so. I don't think so. I mean, actually, I'm wondering if Gleam would be a nicer language than OCaml. But Gleam also does not have the type classes, right? That's what I have learned so far. And like, it has been a very annoying part of OCaml, and I can see it being a very annoying part of Gleam too. Otherwise, OCaml is also pretty cool. Except for the annoying parts of it. One extreme trick you use is to make functions of type ABC, use pattern matching on A, and call specialized functions on each possible value of A, each of which are functions of type BC, and exist in their own file. Yes, because like I have a very big like list of like what a value can be, and it leads to a huge function. I agree with that. Yes. Ideally, a language, I think, should be do you not have, like, you're using Haskell, right? Can you not have type constructor as type or something like this, right? Class constructor, no, Haskell. Can you not treat a specific type that you're holding inside your data constructor as a type? That's a feature that's called something, right? I think it's called like variant types in Rust. It's not there yet. I think they want to have it. Variant types in OCaml. Is that a thing? Variant types? I think variant type should not be leaked though in OCaml, so like you can work with it, but you cannot name it, so like you would not be able to split it. Data kinds. What's the data kinds extension of Haskell? Here's the example. Data nat is z or su nat. So gives rise to the following kinds and type constructor. So nature nat is a box. Z is nat. Su is nat into nat. I'm not getting the point. Kinds. This, that, data kinds. Kind of S is this. Yes. So yeah, I mean, that's not, no. This is not exactly. This is not exactly that, because S is a type constructor. What I want is to treat this, I mean, I guess you know that this over here inside is net specifically, right? But like, let me give you an example of OCaml, I guess. If you have a type, ADT, right, which is either like A of, you know, like A is like an int, for example, right? Or it is B of string, right? So you can do something like when you construct your function, which takes a value of type ADT, right? You can match the ADT with A with A data, right? So over here, this data, what is the type of this data here, right? Is this the kinds? I want to know the type of this type that is inside my type constructor, basically, right? In case of like in case of already existing types, this is pretty easy. One of the ways you can do this, usually without the feature that I'm talking about, is you can extract this anonymous type into a named type, right? So like a data, and you will be able to say a data is equal to this, right? But like this is a little bit too annoying to write, I guess. Sometimes, I think, but basically, easily getting this a data as a type, I would, so you just call this a adt.a. This is the type of the a data. It should be the same thing without you like, and you should be able to still like inline it to polykines. I don't know. Anyway. I mean, you can go around this, like I said, by like having each type constructor accept only like an already existing and named type. Then it's like easy. But I feel like it's almost like a syntax sugar, I guess. So yeah. Okay. Compiler F. Compiler F needs to know what is the type of value. Is that part of the compiler? I don't know. Type of value is. Also, like one of the things in OCaml, I don't know if it's easy in Haskell, but in order to find a function with a specific name, in Rust, for example, you can easily search for fn space function name, because a function in OCaml can start with either a let function name, or it can start with an end function name because it's part of the recursive, or it can start with a let rec. Just doing a simple grep for finding the specific function is not easy. So I need to rely on my language server, which is also really bad in OCaml. And I'm not sure if it's like easy in Haskell, because in Haskell you also don't have a special keyword for declaring functions, right? You just say that function. Yeah, I think that might be a problem in Haskell too. Do you need to do this? Let, rec, and fn name? All of these? Yeah. You just grab all your files for the name of the function, but it also gives you the all the files where the function is being used. What I want to search for and to quickly be able to find is specifically the definition of a function, not the usage of a function. Because the function is being used a lot more than it is defined, you know? It is a lot of work to find the actual definition then. Uh... And then when I copy paste something, wait, what did I copy pasted a little bit too much here, I guess. And I just copy only one function here. Like only this one. Yes, there you go. And it leaves the end behind. Ever. Where is my stuff? Where's my stuff? Why is it not in my buffer anymore? Mm. Dun, dun. Type of value is required but not provided. Do you see this error message? It says that the type of value is required but not provided, and I'm literally providing the type of value here. This language is beautiful. It's hard to do that because you might not have a type signature, so you would need to pattern match and function name arg equal, but Haskell lets you define partially applied function. Yeah, I know. And I think this is also, like, I'm also not sure how I feel about the partial definitions of the Haskell. I think it's okay. You just write a match inside there, or do it like this part in a camel is okay. I just think that the like being like if there was specifically like a function type of value here, right? That would be really easy to find it. Anyway, this is because of syntax not having enough keywords. Syntax is too concise. Do you need double semicolons over here? No. No, there is like this error is misleading here. Let me see in the compiler. Unbound type constructor. It's because like I think it's because it could not find this because I need to open types here. Okay, there you go. There you go. It's just like the error messages of the language server are very misleading, you know, Camel. So I need to have the inference. So this depends on the inference too, right? Inference is modules dot inference. Do I need a semicolon here? How do I depend on multiple things? Or camel functors. How do I depend on multiple things? They only say how to do the one thing. Is it not a comma? What do I need? It's only one. It's only one. How to make multiple dependencies? Do I need to group them into one dependency then? That would be so annoying. Or is it like this is like a function of multiple arguments? Is this how I do it? Okay, kind of makes sense then. Okay, sure. Infer var type. Infer var type. Okay, let's move this to the compiler too. This takes the inference variables, returns the value type, so it's trying to get the type. What is this even again? Inference set type variable for var. The type is a type. Okay, I think this actually belongs not here, into like the inference somewhere. Like when I have the thing works here too. I need to open types, right? Okay. Yes. Var needs to be inference var. If var is inference var, right? So infer var type is basically this, right? The get type. This just gives me a new type variable. Yes, and then I'm going to say that I am setting the I guess a new set var with this. New set var does not exist. Why not? Unite. Checker unite. This should be this unite. Okay. Oh. All right. I expect this to take a very long time. But hopefully it's going to be worth it in the end. Pam. Define worth it. Well, being easier to like find the correct thing, because if I'm working on a like something that is supposed to be related to the compilation, I'm supposed to then go to the compiler. If I'm supposed to work on the inference, then I go into the inference module. Otherwise, I go somewhere else, you know? Like being easier to find the thing that I'm trying to work with. You thought money? Compiler F. Unbound value infer var type. Yes. So this is just supposed to be inference dot get type of the variable, right? Inference get type. Inference get type should then return the value type. And then when I go to the inference, let's see. Get type var is not included. Yes. So let's fix the get type. This needs to I have this type. Can I return the infer var t? And this then is supposed to, yeah, let's just do infer var of that, right? Values don't match, get type. Var. What do you mean var? New set var. Okay, new set var is not set because new set var is somewhere beneath. So do I make this all to be recursive? Instead of let, we use end, right? Okay, sure. Let's make everything recursive inside one module. That just makes it easier to work with. Okay, what else? New set var is still not being found. Why not? Maybe I should do a rec. Yes, of course. Let's do a rec. Let's do and everywhere. Let's make everything recursive. This should do it, right? Okay, nice. Type t value. Wait, what? This is supposed to be new var, right? This is what I want to do here. Okay. Then unite. Unite is me doing inference unite A and B. Otherwise we do so. Yeah, here. Is this supposed to be in the show module then? Is this supposed to be then in the show module? Sure. Show. So if I have the show, I do not have the show. Let's say I have a new. This is going to be lib/show.ml. I open the types. Right? I open the types and I say that let rec show. I'm going to copy this from the interpreter and show. Show2, show event type, show type 2, her name, show that, show pattern. Yeah, I think everything like regarding the show should go in that thing then. Show. Right? This is going to work. I have yeah, this should be the let rec then, right? Okay. Unbound value show or. And show or. Let's show or. Sure. Unbound string map. Open prelude. Unbound my inference. This is just inference now. Oh, wait, hold on. But this, okay, so show depends on the inference then, right? Okay, this is also another one. And module make. Module make is module make inference modules dot inference modules dot show is struct and it this is going to be inference the data the data can be in the types. I think that's okay. Interpreter old data this thing I can move into the types at reg, and this one does not need to be a recursive technically. Show move to show app. No found, no config filed for show app. Try calling dune build. Did you mean type? I did not. Modules inference, unbound modules. LSP. Restart. Does not help. Okay. Maybe it's because of the module show, because I have definitely not made that. Modules. Module type show is sig and. Oh wait, hold on, I do have it. Wait, what? I do have it here. There we go. I have show and I have show type. Okay. What is my current error then? What is my actual error? What is this? No config file for type IDF. It's because wait, what? Why is it even trying the type ID? That's not what I'm not even trying to have the wait, no, yes, because this is a type ID. Okay. No config file found for file type ID. F. What do you mean no config found? What does it even mean? What does that even mean? Is it inference? Unbound module show. Okay, so I'm making it based on the show. Which is going to be modules dot show. Inference. Inference. Make same is literally just here. Set is just here. Fail infer. Interpreter old and fail infer. This thing goes into the inference. And fail infer is raise the failed unite. Interpreter old. This one only has one error. I do not need this anymore. Okay. There's a bunch of built-ins. Everything is red, amazing. Okay, maybe I should undo this just so that not everything is red. Okay, checker. Checker. Do I have don't worry about this file at all. Compiler F, function type vars to type. Okay. Type of value. I think type of value also is something that it's more about like the type something. No, it is in the compiler because of the ensure. Okay. Interpreter old. Function type. To type. Variable type. Pattern type. Pattern type. Type into var. Text type into var. Invert type. Now let's try moving this here. This errors. Okay. What actually is happening here? I have a syntax. No? Do I not have a syntax error? I actually do not. Okay. So it says that the type of value is required but not provided, even although it's directly over here. There it is. What is the actual error then? Unbound module is the actual error, right? Type into var is going to be a inference var. No, it's going to be inference var. Like that. This is going to be inference dot new var. This, yes, okay. My inference dot new var. Inference set pattern data. Pattern data should be template to template type. Function. Okay. String map. I need to open prelude here. Interpreter old. Maybe let's just like start by moving things into different places. A rect block start. I don't need this. Init intermediate representation. This is part of the compiler for sure. This is for sure part of the compiler. Trying to initialize specific intermediate representation. All right. Compiler. Interpreter old. Let's see. We have a thing here, which is called initialize pattern. This one is also there. Right. Same to initialize that. We can initialize a pattern. Type check contexts. Type check context. Does this belong? Okay, anyway, this is the type of function. This is in the compiler. Right. Type check contexts. I haven't been using this function. I'm not sure. Probably belongs to the inference. Template to template type. This is part of the compiler. Just value. Just value. This is part of the interpreter. Update locals. Maybe I should have some module called utils, because this is kind of... new write lib slash utils. And prelude. The type of this constrains the non-generalized thing. This is a thing from string map. It's like value string map t value. It locals pre value string map t new locals value string map t returns value string map t, right? Union rev new locals, right? Open types. Is that what we want here? Okay. Pattern match. Pattern match, pattern value. This belongs into the interpreter. Pattern match. Get local opt. This takes on the state, get local value opt. That based on the thing. Okay, interpreter. All the compile AST to this compile pattern, those things are belonging into the compiler. Okay, still a lot. Still a lot. This is something I don't need. Empty context, default context type. No exception, unwind. This I guess is part of the interpreter. Pattern to value with. Sure where this goes, probably into the util for now. Placeholder. Wait, what? It's a placeholder. Then it needs to be a new inference variable. Which means that I need to have the inference here. Okay, module make inference rules.inference struct. Let's do that. Get type. Type var. Get type. So we say inference dot set data dot type var into type inference get type. So all the pattern data. Pattern data. I guess this goes into just the types, just like the that data. Okay. Substitute function variables. Substitute type bindings. Substitute pattern bindings. And expand AST, expand macro. All of that I think is going to be part of the compiler. Okay. Okay, how much else? 2,000 lines still to go. Alright, I think I have 1,000 lines of just the built-ins here. Like this thing. Wait, no. Where's my built-ins? Built-ins are pretty big. What if I move them to their own file immediately? Module built-ins like this one, yes? Yes. Let's have a new this thing is going to be lib/built-ins.ml, right? And this obviously needs to be module built-ins. It should be a functor something, right? Open prelude, open types. Yes, this needs to have access to compiler. So this is going to be okay. I will fix that later. But now our file is only 600 lines. Okay, so actually my built-ins are 1,500 lines. Okay, we have a lot of built-ins. I should probably like split those into like the macros and the functions, because one of them is about the compilation and one of them is about just the built-in functions. Okay. Find trade ID. Trait is a value which is either a template or a type. Yes. And how about I move all of these into actually the traits too. New. This is going to be lib/traits. Or I guess I should call it casting. Cast kast.ml. Yes. Track. Module kast. It's struct. No. Unbound constructor kast. What do you mean unbound constructor? Oh, because unbound value amdual. But this is module. Why is the error saying unbound value amdual instead of saying module? This is what I actually have in this code, right? Unbound value mule. Is this what is this? Hold on. This language just does not see one of the characters. Module. Unbound value module kast. It's like this space is like not existing there. Syntax error expecting underscore. What do you mean? This language. LSP restart. Okay, actually LSP restart makes it work. Okay. The language server is too bad, too good, I don't know. I don't know. It's too much. Okay. Okay, what do we have? 600 lines left. Right, let's see what do we have here in the end. Maybe let's start from the end. Evaluate. This is part of the interpreter for sure. Empty. This is empty state. Get field. This is part of the interpreter. Yes. Discard. Part of the interpreter. Call compiled is part of the interpreter. Value to context type. I don't know. Ensure compiled. Part of the compiler. Let's go up until over here. Move this into the interpreter. Over here. Okay, old. This one. Let's make these things go ensure compiled. This goes into the compiler. Okay. Old. The eval call. That's from the interpreter. Value to type. Not sure where this goes. Probably into the just. Actually. Probably this goes actually just into the types. Value to type. This one requires the inference though. So maybe not. Value to type. Maybe let's do this in the utils. Over here. Okay. Old. Alright, this function is me evaluating. Okay, actually this is all I need. Okay. This is I'm done actually. Hold on. This file is already empty. Nice. Interpreter. Now the question, like, and then I will realize that all that I have done is actually not going to work, right? Okay. Empty context, default context types. This goes into the interpreter somewhere in the beginning, I guess. Empty type var map. It's even being used anywhere. This one is not needed. Trait impulse go into the trait or into kast. It's the hash table. Okay. Interpreter old. Can I like delete, remove? Can I, from inside the helix, remove the file? Trash. I guess I cannot. Remove lib/interpreter old. Right? Go back into helix, lsp, restart. I don't even have the lsp. Okay, main. Main obviously is not going to work. Okay, let's see. Main built-ins, unbound value, expand ast. Okay, this is depending on the compiler. Okay, and like I said, I think built-ins needs to be split into specifically just the macros and into the functions, kind of, because yes, this should be like built-in. I don't know. Let's have it all inside one place for now. Compiler dot expand ast, which means that the compiler, this thing, needs to be able to expand ast. Expand ast. Expand ast. This is supposed to have this state. State, right? It's supposed to have state into ast into bindings lean into expanded macro, right? Something like this. Unbound value interpreter.empty. Yes, because if I go into the cast, well, interpreter old is actually no longer existing. Rack interpreter, this is it. This is interpreter make. Interpreter f is an alias for this, which is missing. Okay, because it's not compiled yet. Let's go into go fix what? The utils. Is the utils fixed? No, not yet. This just needs to change the my inference into just inference. How about over here? This is going to be inference. Inference dot unite types. Screen says activate Linux. It does. It does. I did not activate it. Indeed. Leave it. I'm living a pirate life. Refuse to activate it. Not giving anyone any money. Show. Unbound value. Show. Okay. Make. This is depending on the show module. Show. Modules.show. Okay. Inference unite. Show.show. Okay. Inference. Inference should be able to have a val unite types. Unite types. Value type. Value type. Value type. I think this is not the correct thing to do it though. But I'm going to keep it. You do. No. Okay, I don't have any errors here. Nice. Lib slash. Okay, which one of them has errors? How do I know which files have errors now? Okay, let's work on the built-ins then. built-ins require inference modules dot inference, right? Value to type. This is part of the what? Where is it even defined? In the utils. And utils. Modules dot utils. So I need to have that too. Modules. Module type utils. Val. Value to type. Value into value type. Okay. Built-ins. Okay, so I will just say that. Let's see. Just say that value to type is utils dot value to type. Or I can open the utils here, right? Open utils. And why not? Eval AST. So I need to have both the compiler and the interpreter, right? And so the eval, this is interpreter dot eval AST. So this means that the eval AST should be state ref into AST into evaled, kind of is what I want. Okay, inference is just inference. Type ascribe. Okay, eval AST self. The expression has type state, but expression was expected of type state ref. State. Okay, next. Compile pattern. This is going to be from the compiler. Compiler, compile AST. To IR. Sure. Init. IR. I'm thinking of opening it. So instead, why do I not say interpreter eval AST? I just say eval AST, but I will open interpreter and I will open the compiler inside here. So modules, they need to tell me that the compiler can compile pattern. This is taking state into AST option into a pattern, right? I have init pattern. This is a no data pattern node into the pattern. Then we will have init that no data that into. What else do we have? We also should have compile AST to that state AST that right? Similarly to expand and AST, one of the two things is going to happen there. Okay. The expression has type. Test types IR, which is not a record type. What do you mean? Compiled. This is the node F. This expression has type IR, which is not a record type. Of course, I understand why, because the compiler is not, when it's compiling STQ this is compiling into the compiled, right? That's what it does. Nice. Update locals. Update locals is supposed to be part of the utils, no? Update locals is over there. Yes, it just needs to be in the modules here listed. File update locals. Update locals is value string map t into value string t into value string map t. For that, I need to open prelude. Okay. Next, update locals. They say still the expression has type value, but I was expected of locals. Okay, actually, I was wrong. I was wrong because update locals is not values. This is supposed to have locals inside instead of values. Local is a different thing, right? Local is a value and a binding. Okay, sure. Unknown value default context type. I think I do not need this at all. Unbound value pattern bindings. Compile list to this. This is the function definitions. Okay. And just say compiler dot pattern bindings. Compiler al pattern bindings. This is pattern into what? Into binding string map. Is that so? Evaluate. Did you mean eval AST or eval file? No, I meant this modules interpreter. We need to be able to evaluate the compiled intermediate representation. Date this evaled, similar to the AST. Next, new function type vars. Compiler dot modules. Well, new function type vars. Unit into function type vars. Unbound value show, which means that I need to depend on the show too. Show is modules.show. Right. I think I just can just open it and show. Unbound value to context type. value to context type and default context type. Interpreter for now, sure. Default context text type. Value to context type. Compiler. Value to contexts type. Value into contexts type. Sure. Built-ins. 12 more errors. Okay. Type ID. Type ID should be a function. So it should be like kind of like type ID.get, right? Or something like this. So I need to also depend here on the type ID. This should have the get, which is a function of a value type into ID, right? Into ID. 10 more errors. There is no expression expected to have the unwind because the built-in functions are only built-in functions that are supposed to be known to the interpreter, because this is only about the interpreter. The built-in macros are about the compiler. Okay. Okay. For now though, let's just say that this is going to be interpreter. Okay, let's see. I'm going to wait, what is unwind though? Unwind is a part of an exception. Can I make the fact that I have a new exception as a part of a module definition? Exception. Unwind. Is this possible? Like this? Right? Sure. Eval call means I want to call. Yes, okay. Eval call. Eval call is a thing which takes a value, which is a function, a value which is an argument, and a context, and then gives me a value back, right? Empty context, not found. Empty context. Somewhere over here. Maybe. File empty contexts. Something like this. Evaluate call. Built-ins, 5 more errors. Show IR is not found. Did you mean show? No, I didn't mean the show that. So I guess show. While show pattern should be also here, right? Pattern into string, and then I also should have show that, which is that into string, right? Then my inference is just inference. Placeholder. This is just that. And then get local value opt. Get local value opt. This is where? This part of the interpreter. I'll move it into the utils, I guess. Wait, what? Not. Well, get local value opt is state into string into value option. Is that what you want? Nice, 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 nice. This compiles. We have a thing that actually compiles. Amazing. A single module has been compiled. This is the biggest one right now of a 1400. Okay, next, since built-ins is done, let's go into the casting. Casting has the type ID. Type ID is type ID dot get. Right, which means that module cast depends on the type ID. Is modules dot type ID. Okay, show. We also depend on the show here. Show is modules dot show. So we'll open the show here. In fact, evaluate. In order to do this, I will need to evaluate. So we need interpreter, which is modules dot interpreter. We'll open interpreter too. Can I make these to be named, by the way? No, it looks like I can only have named arguments to functions. Okay, whatever. So type ID is type ID dot get. Value to type is a thing. And value to type. Is this part of the utils? I need the utils here. Utils, modules, utils. 10. Value to type. We'll open the utils. Okay, my inference.addCheck is just inference at check, which means that I need. Wait, what? Check impl. Oh, I see. Yes, okay. Inference. Modules.inference. Sure. Type ID dot get. Okay, this also compiles now. Amazing. Okay, let's go to the next file. Next file is going to be the compiler. It says empty context type. This one is from the interpreter. Interpreter should have empty context type. Text type. Value mismatch. Get local value opt is required but not provided. Get local value opt. Wait, get local value opt. Get local value opt is specified in the interpreter modules. Get local value opt is not part of the compiler, it's part of the interpreter. Unbound value show. Compiler depends on the show. Show modules.show. And then I will open the show here. I'll probably open okay. IR name is also in the show. Oh, okay. So I just need to say that show has the value name. Like this. You think I should finally activate my Linux? Which will it make OCaml easier to work with? Easier and faster? Alright, I'll consider it. I'm gonna go get some drink. Or maybe we even want to go eat. You know what? Let's go and take a break for food. There is still a lot that I need to do here. You've activated your Linux 10 times to become a 10x dev. Nice. All right. Anyway, let me take a break from this madness of OCaml and go eat some food. Be back in like 10 minutes. All right. Okay. The food is done, and I am back. Oops. All right. You're making a language too. We only made Elixir so far. What's the goal of your language? Is it also going to be the ultimate programming language that is able to do everything? Toy language like Lua? Yeah. I like calling language Lua to be a toy language. Lua is indeed a toy. I agree. Nothing but a toy. All right. The expression has type inference var option, but expression was expected of type inference var. Type var. That's same as other. What? Inference var inference data. Unknown. Type inference data. Type inference data. Our data. Node into data. Other. Dot type var. Okay, so other is this, right? There you go. Just the type is not being inferred, like usually in camel. All right. Eval did not yet found. This is a compiler. I'm going to open the interpreter here. It's okay. Unbound value call compiled. Call compiled is something that is inside the interpreter, right? Interpreter. Call compiled. Compiled. Value. Value. I also need context. In the beginning, right? Okay. So contexts into compiled into value. All right. Discard. Sure. Well, discard value into the unit. Ensure compiled. The expression has type compiled function, but an expression was expected of type compiled. Okay, not compiled, but compiled FN. Makes sense, makes sense. Unbounded value to type. Value to type is in the utils. Okay, utils modules.utils. There you go. Value to type. I need to open the utils. Okay, next. Get field opt. Get field opt. Is part of the interpreter. Val get field opt is a value name value option. Name is a string. Okay. Unbound my inference. Let's just replace all of the my inference with just inference. Get local opt. Get local opt. Get local opt is part of the interpreter module. Okay. Get local. We have already the get local value opt. And then there is a similarly to that the get local opt, which is giving you not necessarily a value but local. Okay. Then unbound value log state, because this was not found in the current scope. Log state. Sure, let's have it in the interpreter. Exposed val log state is a log level into the state into the unit. Unknown value show or. Show or is part of the show. I'll show or. Show or is a polymorphic function for all a's. Something like string, which is the default. And then a function taking a into converting it to a string, and then I have an optional, and then I have a string as a result. Okay. Show fn ast. Show function ast. This is going to be function ast into string. Not value show function type. Yes, so we should have also be able to have show function type. Function type into string. Okay, what else? Unbound value type ID. Type ID is more like value to context type. Is it even being used? Context. Okay. Matt, type ID get. So now I need to have the type ID here is another dependency. Type ID modules dot type ID. Okay, the compiler is also compiled. Inference unbound value ensure compiled. This is going to be part of the compiler. Compiler is modules.compiler. I'm going to open show and open compiler here. I think signature mismatch unite types. Inference. So yeah, inference unite should just be renamed into unite. And unite types. LSP did not respond to prepare rename request. This language server. Restart. I just need to, okay. Inference underscore unite. Replace with unite. That's how I can do it, I guess. Signature value new var unit var is not included in modules inference. New, because I have new var. Wait, why do I have my inference here? Oh, camel moment. Insane. Hello there. Camel moment. Well, every language has its moments, but I feel like I don't know. I don't know. I guess yeah. I guess every language has its moments. It's okay. It's okay. It's just that I'm using OCaml right now, so I'm having a lot of OCaml moments, right? Right? Nothing actually wrong with OCaml. OCaml is a nice language. Rust definitely has its moments with Rust Analyzer. Yes, indeed. Which is part of the reason why I was not like using Helix, for example, for the Rust, because it was breaking all the time inside Helix or inside NeoVim for some reason. So I'm thinking, yeah, at least, yeah. I don't know. But like Rust Analyzer issues are not that often. I guess the Rust moment is usually when you like need to like do something with like pin async and like lifetimes at the same time. If you don't know how to work around those, then you're going to have a Rust moment. That's what usually happens, I guess, in Rust. I don't think that Rust Analyzer has a lot of issues. It is like it is 1,000 times better than this language server. Mm -hmm. Modules do not match. New var. And new var is actually not here. Why not? Server error -32803. Amazing. New var. Look at this. New var is actually literally here. Unbound value. Ensure compiled. Value get inferred is required but not provided, even though it actually is. Okay, where's my actual error? Can you give me not fake errors, but proper actual errors that I have here? Open prelude. Maybe this is the one that's missing. Oh, Camel LSP, when one symbol is missing, everything is wrong. Yes, that's exactly what's happening with OCaml. That is exactly it. If you have one error somewhere, then the entire program, the entire everything is going to like be covered in red. Okay, and then like you need to find it because like okay, maybe it is my inference. That's probably it. That is probably it. My inference is now actually just inference. That is not it. Okay. Module inference is alias for inference, which is missing. Yes, because I am inside inference right now, actually. Hold on. I guess all of my inferences need to just inference dot. Like, I should not have inference dot. Should just remove that here, right? Yes. Okay. This was still not it. Okay, let's see. Unbound value ensure compiled. Ensure compiled is inside the compiler. Maybe because I do not have it in the specification there in the signature. Expression has type value type, but the expression, where's the actual error? I don't even see it. Unite types. Sig end. This is what I get. Like if I want to know the type of this, the type of this is sig end. Amazing. Amazing. Alright, let's see. Call compiled and ensure compiled and empty context. I think it should like be make dependent on the interpreter too. Modules.interpreter. Can I like open the interpreter here and see? So now the ensure compiled is the thing that is not existing. Ensure compiled is a function over somewhere. Ensure compiled. Right now is inside the interpreter. No, hold on. This is inside the compiler. Yes, okay. Let's go into the modules. and compiler. I should have val ensure compiled. This should give this is a thing that takes a function and makes the compiled function, right? Okay. Okay, this is main. This value does not matter. This expression has type value type, but expression, okay. So fail infer. What is a fail infer? What is a fail infer? Fail infer should be can it be the hold on. So if I have a function which is literally like raising an exception, this should be a polymorphic function, right? So this is a function which takes unit and returns this polymorphic thing, right? This is a function like that, right? This is correct. Variable unite is bound several times in this matching. There you go. There you go. This was the actual error. And unite. Um okay. There you go. No more errors. Amazing. Unused variable B. Unused variable variables. That is okay. Alright, next. Interpreter. Signature mismatch. The exception unwind is required, but not provided. What is this over here in the very beginning then? Are you stupid? Oh, camel. Alright. Okay. What is my actual error? I need to open types. I need to open prelude. I probably want to value empty state is required to provided. That is not true. Don't give me the wrong errors. Unbound value show. I need to depend on show. And I'm going to open show. I'm going to probably depend on the utils. And I'm going to open the utils. And let's open the compiler. Unbound value, interpreter.empty. This is, no, this thing. My inference, okay, yes, sure. So we need to have the inference here. Inference. Modules dot inference. Okay. Why do I have my inference here anyway? Pattern match opt. Yes, that makes sense. Okay. All right. So what I need to do is to have inference. So my inference is changed with that inference. Okay, next we have unbound value evaluate intimate representation, even though I'll actually have eval this literally here, because this needs to be an end or something. And everything needs to be recursive. Can I find a let which is in a top level position somehow easily? It should be empty state. Unbound value built-ins.all. Yes, so I need to depend on the built-ins here. Okay. Built-ins the modules.built-ins. So this is a new thing that I need to have. see, module type built-ins is sig and val all is value string empty. Think unbound value type ID. ID is another dependency. Type ID modules dot type ID. Okay. Type ID is type ID get. I'm not just going to do that. Signature mismatch. The value empty state is required. Yes, because and empty. Instead of having empty, I'm going to rename it into the empty state. Okay. Then do not match eval file. Eval file is not included. I think this is the wrong error. Unbound value inferred type. Inferred type is inference dot get type of this type variable, right? Yes. Next, unbound value inferred type inference dot get type of this variable. Okay. Unbound type value find trait ID. This should be traits. This should be wait, evaluate value type, the value impl evaluate that. Yes. I feel like I need to over here. Okay, so we have the it's called casting, right? It's called casting, which means that I have a cast here module type cast. Module typecast is this where? So cast. And to find brainoid. Find trait ID. The value into ID. And are going to have find get impl. And check impl. Get impl. Value. I think this is it. Check impl. Value, trait value into bool. And then add impl. Add impl. Value type. Add impl. Value, trait value. Impl value unit. This is what I want, right? Interpreter signature mismatch. I guess one of the easy things to do here is actually like the reason I have this all red is because I say the colon this here. If I don't do this, then I have the actual errors. This is so yeah, okay, I understand now. My mistake. Specifying too many types. All right. Okay, so this would be something like kast dot add add rule type create simple. Okay. Next. See over here. Add rule. Add rule. So we have a type. We have a type which is a value. Think. Have a rate, which is another value, and we have an impl, which is another value. Return unit. This is what we do. Type ID is type ID.get. Right? Show type. Okay, yeah, sure. Value type. Although I thought I would add the rules for not necessarily the types later. And also, I'm not sure if I like this feature of Helix, where I go over this and it just like shows me a new page completely instead of scrolling. All right, type id.get context type, substitute type bindings, substitute is part of the compiler. All right, and context type, substitute type bindings. Maybe substitution would be like, yeah, this still compiles, so I think this belongs to interpreter then. Add rule, kast add rule. Okay, so kast is not this. I want to go to beginning here and add it as another dependency. Kast modules.cast. Cast module. It's a thing which should be able to get impl, add impl. Okay, this is going to be add rule. Get I don't know. Let's cast perform. I will rename them while I'm at it here, and then cast check. This is going to be like just checking the possibility of checking of doing this. Unbound get impl. Okay, so get impl is going to be cast dot perform, right? Cast perform. This is state, and this is the get impl. Check impl. So I think that part of this thing, check impl, since this should not be check impl, this does not need to be test. All I need to do is check impl trait value. Why is it has a trait as a value here? And interpreter over here. Trade is evaluate. This is get impl, right? So I need to have a trade and value here, right? This also does not specify the captured and data, so we do underscore, sure. We literally just do this, cast value, cast perform. This gives me a value. Cast perform, perform value into trade. Value, trade. That's what I need here. And check impulse should also be trade value and underscore. I do the same stuff, but after that, we return a boolean, which should be over here, cast dot check value trait, right? Okay. And then unbound value infer type. Infer type is inference dot get type, and type ID is type ID dot get. Contexts. Show contexts. Two parts of the show then, I guess. Modules show. Well, show contexts. Contexts string. Okay. Find trade. Okay, so check impl. Yes. Instead, I will just have check, which has the trait and value. Check value trait. And that is it. I am matching the value with type, but value is of type value. Okay, there you go. Okay. Get impl. This is going to be called perform now. This takes the value and a trait. So this we match. So yeah, trait is also value. Okay, and then we do that. Nice. Next. This expression has type, value type. Expression was expect of type value. Push-ups, alright. Arjinga, hi. Hold on. And done. Okay, this is type value. Type was expression that was expressed of type value. Type value to type. Why do I even need the value to type here? Create impl. Do I need to convert this into the value to type? Type. I don't know. Unbound value infer type. This is inference dot get type. Okay. What else? We have 3 errors left. Signature mismatch. Of course. Of course, we have the signature mismatch. Because it is a functor. Alright, so there you go. This. We need a compiler. We need a show. We need utils. Compiler. Show. Utils. Inference. Built-ins. Type ID. And kast. So this is where There's a syntax error. Oh, okay. Can I do all these things here? No, hold on. Am I actually supposed to like grab every single one of them in a bracket? More brackets. Of course. Why not? Let's do that. Okay, very nice. Functor application is ill-typed. These arguments do not match these parameters. Of course. Of course. Compiler. Compiler F. Okay, let's also go to the file called kast. This is now this thing. I should rename it. Move to the lib/kast f.ml. Let's go to the file called inference and let's move this to lib/inference f.ml. Let's also move to utils and move this file to lib/utils f. Let's move to types. No, types is the only one that is the correct one. Built-ins though also should be moved to lib/built-ins f. Right, and then into the and then finally into the kast. Not this kast. This kast. Okay. Let's go into the modules. And let's okay, I can do this. Unbound module. Yeah. Unbound module show. Let's see. And show modules.show is equal to show f.make. Right? Show f. Unbound module. Did you mean show? No, I meant show f. So well, hold on. This is already called show f. LSP restart. LSP restart. No config file found for file show f. Why not? Why is there no config filed for my file? By calling dune build. But that's what I'm doing. Oh. My dune is running in the background still. Maybe it broke completely. Unbound module kast. Okay. Unbound module kast in the kast ML. Kast ML. Okay, and kast modules.kast is kast f.make. Right? And then over here, kast f.make. This one. I cannot go to definition. All right. Type ID, show interpreter, inference, util. Type ID, show inference, interpreter, util. Okay. And util modules.utils. This is utils. Okay. Is utils f.make. Make. This is a functor from inference and show. Inference and show. Alright. And inference. Modules.inference is inference f.make. This one is show compiler interpreter. Show compiler interpreter. And also and type ID is modules.type ID is type ID. Okay, let's go to the file called type ID f. It is already called type ID, so type ID f dot make, and then whatever I need there. All right, next. Do you mean built-ins? Okay, and built-ins is modules dot built-ins is built-ins f dot make. Okay, interpreter, compiler, inference. Compiler, inference. Something like that. Utils show type ID. Utils show type ID. And this is ill applied. Would that be ill applied? Signature mismatch. Values do not match. Unbound module show f. The functor application is misapplied. Show f. Show f. Show f. Inference, and that's it. Inference. Okay. Function is ill applied. What do you mean ill applied? Show f. Like, I mean, I cannot even go to the definition. LSP restart. Please. Unbound module show f, because it still cannot figure it out. Okay. The functor application is ill applied. These modules. These arguments, inference, do not match. But how do you know if they don't match if you don't even know what show f is? The functor application is ill typed. Kast f make. Kast f type ID show interpreter. Type ID show interpreter inference utils. This should be after that. Okay, because we don't have the named arguments for the functors. Can I have OCaml functor named args? Can I not? Like, the labeled arguments are only a part of functions, right? Only functions can have labeled arguments. Is that right? Why not modules? Why are modules so much special? Utils f make inference show inference is this anything not found? Signature mismatch. Inference type, hold on, inferred type, mutable type function, cast inferred, something, interpreter type, hold on, argument, functor type. I'm trying to refactor my code, brainoid. And OCaml is not very easy language to work with. You liked it when it was spaghetti? So yes, I'm just making my spaghetti a little bit more explicit. Over here, you can see that I have a lot of recursive modules, right? And I'm making my spaghetti explicitly spaghetti. You know, everything depends on everything. That's what this file over here specifically is about. It's about showing you how spaghetti my code is. Everything depends on everything else. All right, I just need to understand what the hell this error means right now. Signature mismatch. Maybe there is some other like thing. Let's see. Maybe it's because over here, no config found. No config found. Yes. Why is there no config found? Why is there no config found? Okay, you know what? I know exactly what I need to do. I need to select everything and comment it. Because then I will see if there is a problem in some other file. Yeah, why is there no config found for file type IDF? This makes absolutely zero sense to me. Why is there no config found? Why? Why? This is why, because I have... Okay, this is the actual error message, alright. In the main, kast interpreter all impl. Wait, hold on. Yes. So this is so stupid. Why am I seeing... So like, you see the actual errors that I have? There's only one error. Everything compiles and there's only one error. In my language, and my language server says that I have a billion errors instead. Why? Why is it so bad? Main interpreter is... Let me just comment all of that too. So that, like, if I comment everything, I have no errors, right? It still says no config found. Okay. Even though my thing successfully compiled. If my thing successfully compiled, then why am I still seeing the errors? LSP restart, please. And it still is not working. Okay, hold on. There you go, hold on. We say Dune build. Screen is terminated. Wait, what? Is there a screen, still a screen there? Yes. Screen, resume the Dune. Okay. Okay. Alright. HTML. We're done with mutables, by the way? No, we're not done with mutables. Mutables need to be controlled. We need a borrow checker. Do you know what borrow checker is, Brainoid? Did you try a little bit of Rust maybe at some point in your life? Or have you ever, since you have worked with like C++, felt the need for a borrow checker? Have you been debugging the seg faults in C++, I wonder? Like, how much code do you actually write in C++ when working with Unreal? Because you can do a lot with just the blueprints, right? That would be pretty safe, probably. But I mean, even without the C++, even in C#, you can easily like for example, I guess you can do something like iterating over a collection of data, like iterating over a dictionary or iterating over a list. And while you are iterating, you can on accident mutate the list by adding a new element. So what is going to happen? I think depending on the language, but I think most of the languages, they throw an exception. Collection modified while you were iterating on it. Something like this, right? C# will throw an exception. Yeah, so so it means that it is easy to, but it does not. C++ will just crash saying nothing. Lol. Yeah, so exactly like that. So like borrow checker, it not only like prevents you from the memory issues, because C# is still like a memory safe language. It just helps you find more bugs that you can write at compile time, and that is one of that examples. So you can say just like I don't know, yeah, it's just like about finding these bugs in compile time instead of figuring it out at runtime. And yeah, that's basically it. Yes. Okay, let's see if this still works. Okay, I just need still signature mismatch. Values do not match. Eval file is not included. Eval file is not included. Interpreter make eval file, but it is included. It has okay. It's I think it's because file name this one it was supposed to be named, right? Okay, there you go. Show make inference. Show F is unbound module. Did you mean show? No, I meant show F. Show F is literally over here. It's because over here. Unbound modules. No config file. Wait, what the? Okay, unused show F. Just about mutable progress, because he was going to ask if you can create a thread safe singleton to get your code. Even more. To get your code even more spaghetti in kast, can you create a thread safe singleton to get your code even more spaghetti in kast? Well, I mean, I don't have threads yet. So thread safety doesn't really like make any sense yet. If I don't have threads, right? Doesn't have to be thread safe. That's even better. Have you are you saying that because you have been debugging a lot of problems because you are using singletons and they're not thread safe? Unbound module show F. Why is it unbound? Can someone tell me why is my module unbound? Lib. Because there's literally a file called show. Wait, where is it? Where is it? Okay, I think I see the issue then. Show F is in root, right? Am I right? Show F is in root, and type ID F is also in root. So can I move this one? Move to lib / show F. There you go. I still have the error. And then can I move the type ID? Move into lib / type ID ml. Okay. Do and build. Okay. It's not built. I have 1,000 problems, and then get is required but not provided. Okay. Okay, let's run it in the screen, and then signature mismatch. Okay, type ID, I need the get. So get is a function called type ID. So I need to just rename this from type ID into a get. Build failed. Amazing. Show F is an alias for show F. Kast. The application is ill-informed. Modules kast F make. Can I go to the definition of this? No, I cannot. Type ID show. Interpreter inference utils. Please. Have one error. They don't even see. Do and build. My inference dot show ID. This is in the show F. Show F. My inference. Just inference. There's more problems here. Type ID dot to type. Type ID dot to type. So type ID. Type ID ML. I'm not supposed to even have this one. Right? Do I not have type ID? Yeah, this one should be moved into type, into lib / type ID F. This is a functor. Alright. This is a functor. June build. What else do we have here? I should probably like start fixing my warnings then, because the errors are mixed with warnings. I need to scroll too much. Type ID to type. Okay. So I need to go into modules. Type ID. This should have a to type. to type. This is like the inverse conversion from ID into the value type. There you go. You're saying this because this is general opinion of the community. You're experienced enough to handle singletons. You have no issues with them. I mean, the general opinion of the I guess programming community in general, not specifically about C# or anything, that singleton is an anti-pattern. I think what most people say. Because at some point you will want to have more than a single instance. You will have to rewrite the entire thing. Or maybe that's not the reason. I don't know. Why is singleton an anti-pattern? You like to have only one singleton in your games and have all managers under it? This is used to simplify code without thinking of the difficulties. This also applies to static classes also. If you have unit test or have concurrency, then the state of the request will change and the state may cause problems. I think the way we solve it here is using the context system. I don't think you are. I think instead of using a singleton, what will happen is that we have this context system in kast, right? So you should always like basically while running your game, you should have this like singleton in your context. It doesn't need to be actually a singleton, but you need to have a value of this available, right? It's just like very easy to make a singleton instead of having it like as an additional argument usually, which would make it very verbose if you need to like carry this object everywhere. That is just makes it very annoying. Kind of like how Zig solves the allocator problem, where you just need to pass, like if any function can allocate, then you need to give it the allocator as part of its arguments. So this means that you need to carry your allocator everywhere. And if you need to carry other things, then it's just going to grow. This is to the contrary of the normal languages, of the other languages like Rust, for example, where the allocator is actually just a singleton. But it also introduces some other problems, which is what if you actually want to control your allocator? What if you want to not use the singleton, but actually have in a specific function to use like arena allocators and shit? So there is a trade-off right now, and I plan to solve it using my context system, which is basically going to be easy to use and at the same time be very controllable. But that's the idea for now. I'm not sure if maybe I don't know. Show if it's an alias. Type IDF. Unbound module prelude. Let's see. What is my actual error? I'm almost done. Where's my error? Too many warnings. Where's the errors? This one. Type ID.toType. Is it still the same one? Clear. Doing build. Okay. Yes, this is it. Show F line 88. Type ID dot to type. But why? Because it does not depend on the type ID. That is why. We need to have type ID, which is modules dot type ID. And then this should work correctly. Then my inference supposed to be just inference. Okay, new question. Do you have a nice word to translate reroll in Russian? You're translating retro to Turkish. And difficulty translating reroll. I'm trying to remember what they use in other games. Yeah, I understand that reroll in a shop, and I don't know. I think I'm playing all the games in English, not in Russian, so I don't know what the word they use there. Do you have a problem translating it to Turkish too? And on module kast f.make. Module make, exactly. This is supposed to be module make. Type ID f.make. The functor was expected to be applicative at this position. Type ID f. Type ID f.make. I need an inference. I need the inference here. Tune build. Built-ins f.make. Unbound module built-ins f. Built-ins f. Cool. I think you're gonna do something like shop refresh. Like a restock or something is what you usually use for shops, no? If not reroll. But I don't know, for English you can just use the reroll. Modules do not match. Functor is not included in functor. Functor type ID. Show f. Make type ID, yes. Cast. Show make type ID. Okay. Build. Values do not match. Add rule is not included. Add rule is not included. This is about the casting. Add rule. It is included though. It is supposed to be of type modules dot cast. Add rule value type trait and impl value unit is not compatible with type value. Okay, this is supposed to be value or the value type? Value to type. I guess I just do this. Value do not match. Update locals. Yes, indeed. Modules. Update locals is No, update locals is locals, right? Utils. Update locals. This is supposed to have a local. Compiler F make interpreter. Yes. Kast. Compiler. Compiler make interpreter. Inference show utils type ID. Inference show utils type ID. Okay. There's no way. Imagine. So amazing. I have spent 5 hours doing this, and then the OCaml says that it cannot safely evaluate the definition of the following cycle of recursively defined modules. There are no safe modules in this cycle. Okay, so the way that I was planning to do this absolutely does not work. Why not? OCaml, safe modules. What is a safe module? A module is safe if all value definitions that it contains have function types. If all the definition it contains have function types. So a safe module is like the Rust trade object safe, right? It means that for recursiveness it needs to be like able to be as a module, to be treated as a module object, right?
20.
Hello, Davey. Hello, Davey. How are you doing? Cannot safely evaluate the definition of the following cycle of recursively defined modules. There are no safe modules in this cycle. What do you mean? And none of the modules are actually safe? Or are you saying that I look old? I'm writing OCaml. Who do you think writes OCaml? It's making me older. Every day I write it. How are you doing? Are you ready for the great rewrite of Linksider into the kast from Rust? You went traveling in Korea? Nice. And how old is Davey himself? No one knows. Rewriting. Rewriting is always POG, right? You want me to optimize the game, and optimizations is not very easy. It's probably easy to rewrite the whole thing from scratch there. I just need 2 more years until I finish this language, and then we can rewrite it. I don't know, maybe 5 years. Rewriting Godot, please. I'm not going to do that. Personally, no. I mean, actually, what if we do Godot and Rust? So the rendering is in Godot, but the backend is in Rust still. You can finally be the programmer, but if you are the programmer rewriting it in Godot, then isn't it you who should rewrite it in Godot? How long do you think will it take you to rewrite the whole Linksider into Godot? Probably 2 years. You're a new programmer. All right. So it's not going to speed it up really. Okay. Not sure writing it in Godot then. I cannot safely evaluate the definition of the following cycle of recursively defined modules. Interpreter, built-ins, interpreter. Interpreter, built-ins, interpreter. There are no safe modules in this cycle. Let's take a look here. Interpreter. Modules, interpreter. Like, is it because the interpreter is having an exception and this is a type? Because this only has a... But if you code logic using Rust and render using Godot, it might be viable. You'll look into it. Then we can just like reuse most of the existing code. You just need to redo the rendering, right? That's all that needs to happen. If it's not that hard, we can do that, I guess. Because the backend, like, you already will just be able to know what is the current state. So I can keep the current like interpolation, like the history and everything. You basically have a we basically have a backend, and we need to change the front end, right? I already know exactly what you want to draw, and how exactly you draw it is the only thing that you want to change. When is the next Godot gem? Godot Wild Gem. Is it every week? Or is it every month? Gem ends in 0 days, 0 hours, 0 minutes, 0 seconds. Amazing. By the way, you have some mega impossible levels you made on a plane. Nice. You want me to check them out right now? Or did you not commit them yet? So, hold on. The issue, they say interpreter into built-ins into interpreter. So technically, interpreter and built-ins, one of these should be safe module, right? Safe module means, once again, safe module OCaml safe module. Safe module just means that all definitions contains have function types. So everything should be a function, not even a value, but a function, right? So inside the interpreter or inside the built-ins, we should have that. Built-ins has a value. Built-ins, as you can see over here, has a value which is not a function, right? And the interpreter, in interpreter, actually almost everything is a function except for the exception. Exception is not a function, right? So I can have the exception unwind inside of my types technically, or something. Or I can make this built-ins all to be a function of unit, which gives me this all built-ins, which constructs a new built-in. Yeah, why not? All. This. Does that make sense? Does that make it safe? Okay, we did go further, for sure. Okay, and now built-ins all. Okay, that's how we do it. Alright, I understand now. So built-ins.all over here is just going to be a function that I call to get all the built-ins. Nice, it's built. Just REPL. Just REPL doesn't work. Oh, I mean, okay, because my main now, okay, now my main is completely like this. So when we say that the interpreter is cast.interpreter, right? Interpreter empty state is what I do. And then I say, I guess I just open the cast here, right? I open cast. Random syntax error. Open cast. Semicolon. Semicolon. So this is not interpreter show. I need to like then open show, right? And then instead of interpreter show, say just this type of value. Type of value is part of the compiler. All right. Open interpreter. Open compiler. How about I just open everything here? Okay. Dune build. Just REPL. Amazing. When uniting int32 and string. So this is the same problem as I had before, right? This is finally me going back to the original problem that I was trying to solve, but we did compile. Do I like the new changes? We have, instead of one file made out of 4,000 lines, multiple files which are smaller, and I know how to split things. Okay. Should be a good change, I think. I think this is a good change. Okay. Split code into multiple modules, but they are functors because it's OCaml. All right. Okay. Let's now so now what happens if I check out the main branch and I go into the REPL? It's literally the same issue, right? It literally is the same issue. Okay, doesn't really matter. Git checkout refactor. Let's go back there. Just REPL. Okay, so the problem once again is this. All uniting values eq. Yes, it's because of the eq. It is because specifically of the eq. So what I was going to do, finally, we go back to this thing, to the actual work, right? I want to introduce a new intermediate representation thing, right? So we go into the types, and I go into the intermediate representation in a node, right? So one of the new things. Right now I have the node, which is a built-in function, and I do not want this to even exist technically. Instead of having a built-in function, I will only have just a built-in. A built-in to do remove built-in function. because yes, built-in function can only exist if I know the target. Built-in, and the built-in is supposed to know the name of its built-in, right, which is a string, and then the data, like that. Okay, so over here, built-in data allows me to get the data. Okay, then unbound value show. All right, hold on. The compiler. Unused variable. Why is unused variable is an error? It's not an error, it's a warning. Hello? This is the error. So when I'm initializing a built-in name and data being no data, then over here I need to initialize the types, right? So this is of unknown type. This is of unknown type. This is my data, and the name is still the same. All right. This is all I need. This pattern match is not exhaustive. Here's an example what is not matched built in, but it literally is over here. Is the language server still not aware of the fact that this is actually handled here? Can the language server be more? This is literally handled. Look at this, built in. It literally is handled. Okay, I'm going to literally is handled. Hello? I do have an error that doesn't exist again. Let's go into some other file. Okay. Compiler. Show. Built-in underscore. Built-in. Oh, file modified by external process. Maybe that's, yeah, okay, that actually is the case. That's why, because I was changing, yeah, because I was changing the thing. Okay. Built-in data. Oh, data name. Yeah, because the Helix does not automatically reload my files. There's no way to do this even in Helix for some reason. Okay, there you go. And then over here when I'm showing the built-in name, built-in string escaped name. Let's do that. And then in the interpreter, when I want to actually know what is the built-in, this is where I construct the built-in value, right? Right. Over here. Built-in name underscore. So I just have just value, and I need to have like the built-ins, right? So I need to find and to do a string map dot find name in the built-ins, and the built-ins are going to be like somewhere over here in the beginning, and I let built-ins is built-ins dot all, right? Something like this. Built-ins dot all are also used over here, and they should not be used here. Over here I only want to know about the built-in macros, probably. Actually, probably not even about those. Built-ins should not pollute my my global namespace. I think. Okay, anyway, does that work? Just REPL. Undefined recursive module. What do you mean, libcastml? Wait, what? Wait, what? I have an wait, hold on. So the code has successfully compiled, but when I try running the compiled code, I have a runtime error for undefined recursive module. What? The code compiles but doesn't like run with undefined recursive module problem, huh? Because built-ins, because init mod field. Oh, okay. I see it. This language is so funny. I understand. Come internal mod. Init mod field. So I'm trying to initialize the built-ins because this is like a value, right? It's like doing this. But the recursive module, my dependency, is not yet initialized. It's like when your singleton is depending on another singleton, and that singleton is depending on your singleton, and you have a cycle of singleton dependencies. I guess. Why does it even compile then? All right, sure. Okay. I think I can like initialize the built-ins first actually. Do this module rack. I'm pretty sure that I should be able to just initialize the built-ins first here. No, I cannot. All right. Because I need to initialize all of them. All right. Okay, fine. Fine. Let's solve this problem in a different way then. Built-ins. So it means that I need to not use a singleton like this, but I need to actually store this thing inside my state of the interpreter. The interpreter is the one that knows about its built-ins, right? Types, state. So state is this. The data is that. Context is this. Struct is that. Why do I even have two things here? State. Pum, 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 pum. Okay, actually, you know what? I know exactly how to fix it. Say that built-ins is not built-ins all. Yo, done. You moved the files from the phone into the thing. Hold on, I'm also almost done, I think. I just nah, actually, you know what? Let's do it the correct way. Instead of the hacky way. Maybe if this can be considered correct. Inside the state I will have the built-ins. since this is the interpreter state, interpreter should know what are the built-ins. Built-ins is a value string map t. There you go. This is all I want to do. Interpreter f built-ins. So I think in this case I will not even have a union here. I just need built-ins to be built-ins.all, right? And that is over here. Built-ins, unbound value built-ins. So it's not built-ins, this self.built-ins then, right? Yep. Yep. Okay. Now it's not going to find something, right? It's going to say something like built-in macro then is not found, and this find local. Let's see if I find local. Find local opt. Find get local opt. Get local opt. Right? This is the one. So get local opt and get local value opt. In this case, I want to see something like match cell built-ins, a string map find opt name in built-ins with some value or none. Then we do the other match. How about this? Just REPL. A void not found in the current scope. Yes, void is indeed not found in the current scope. Stdlib void. So like what I'm thinking is that the void const void I don't know. Maybe I should have the both there actually. Or can I literally just do the const void is equal to the built-in void, right? That's what I want. So this means that I need to have a built-in somewhere. Somewhere over here. Syntax, built-in macro.
Wait, how did void work before though? Built-in macro, built-in is built-in name. I think this is what I do. You go into the built-ins. Yeah, I mean, yeah, built-in values don't. Yeah, this is why. This is why because the built-in values don't have the prefix to them. These are the things that. Okay, yes, makes sense, makes sense, makes sense. I think I should still make even these go through and defined in the standard library, because otherwise they are implicit. Very good. Okay, so I need a built-in like this. So built-in is a built-in macro with name being built-in, and with implementation being function self args new bindings into assert not new bindings into compiled image representation, which is a built-in name data is node data, then initialize bindings is string app.empty. Okay, this is good. This is good. And then I need to find the name, right? So name is how about I do just evaluate string map find name in the args. So like technically it does not even need to be a constant then, right? I just need to evaluate it, and then I need to match the evaluated stuff with built-in value with built-in name supposed to be a string colon show value. All right, and then if I have an actual string s, then I had the s. There you go, there you go, there you go, there you go. This is what I want. String is not found in the current scope. Yes. So how about I just go and do all of these? This is what I want, right? All of these. I copied them, and they all need to be defined in the standard library, right near the const, right? Someone told me like something like join, yank join selection. A separator can yank join selections. Okay, so that's what I had to do actually in the previous file, right? Over here. And to do a yank join. Helix is amazing. You just start using it. Yank join. Yank join means that I'm going to copy this, just like in VS Code, I'm going to copy multiple selections, right? And then I go into this other file and I want to just paste them here. There you go. This is exactly what I wanted to do. And then I'm going to just go here and I'm going to say const this is equal to the built-in, like this exact thing, right? So copy this, I go to the end, and then I do this, right? There you go. Yes, working with multiple selections is so much better than the macros of the NeoVim, the Vim. Okay, this should be good enough, right? Okay, what else? What else? Why is my stack trace so big? Built-in function equal is not found in the current scope. Okay, so now instead of having a built-in function input, right? I'm going to like say this everywhere basically. So instead of doing this, this is going to be equal to the built-in input, right? I guess I don't even need to. I don't even need to. Let me call it function input. There we go. Like, because yeah, this is good enough. Function print built-in function dbg function x. Like, I don't even need this, right? I just need to say, instead of that, I need to say built-in function dbg, which is t into void. You always use %s for that kind of stuff. %s. Yes. But s is only doing the substitution, right? I forgot what the s is about already. Like, I was copying the thing from one file into the other file. The %s would not help me with that. So built-in function panic is instead panic is string into never is going to be equal to built-in function panic. Okay, random is for all. Built-in function random. Then I say built-in function. Built-in function random int32. I should just have these things to be the same. Random float 64. And this should be just panic WTF, right? Okay. Built-in. Okay. Impl x for int32. This is going to be equal to built-in function equal. Okay. Built-in function equal. Built-in. Built-in function binary plus. Built-in function binary minus. And this is just equal over here. And this is going to be built-in function less than. Go forward. Parse built-in function string to int32. Nice. Parse for float 64. Built-in function string to float 64. Built-in function sign. Built-in function sign. Built-in function delimited block. Okay, this is going to be without all of that, right? Built-in function delimited block. Nice. Built-in function delimited yield. Yield is built-in function delimited yield. Have type yield into resume. Built in. Okay. Okay, not all of them are. Yes, because the function type is still a function. Built-in function, not a macro, right? Maybe it will already work. Built-in cannot finish at 228. 228 over here. Then built-in function. Okay, built-in function should actually be then built-in macro built in this one. Actually should be pretty high priority, right? This should be pretty high priority. Probably similarly to the struct definition, maybe even this over here. Let's make it 500. Okay. Now the problem is that expected an AST. What expected an AST? I was compiling something. I was calling args. Name is yield. Type is type. Yes. This is an AST, and this also is an AST. I was trying to compile the pattern inline typed field. And the problem is expected an AST. You know what? How about we go into the flake nicks and I comment out the OCaml B param again. I do not need this anymore. Okay, so we have expected an AST somewhere. Expected an AST. This is inside the interpreter. When I want to have an AST, evaluating the AST, did not give me the AST. Instead, okay, expected AST, expected AST, got show other. Right, let's do this. Build finished, REPL. Let's say expected AST got type. This is wrong. Because this is supposed to be an AST, right? I am evaluating the AST values is this. What about a name? Let's do a map I function name. How about I say something like a name expected to be an AST name expected to be an AST, but we got this thing. All right, let's go. So we say specifically a type expected to be an AST, but got type, right? So we over here type colon this, right? Yes, this is a quote. This is an AST. AST type. What did I break here? Well, I definitely. Well, I got I no longer have the built-ins in my global scope. That is something that I don't have anymore. I have built-ins in my current scope. Doesn't matter anymore. Did I change anything else here? Not really, right? I didn't change that much. Okay. This while compiling const let at 313, 317, 313 in the stdlib 313, 317. This is specifically the thing that cannot compile here, sign, right? Wait, what? 313, 317. This one, const yields, actually. This is the one. This is the one. I have the wrong span information. Need to fix that at some point. 317. So this thing, the const yields, it's trying to like parse this stuff, right? It's trying to parse this stuff. It says over here I have an inline thing, which is like type, right? So it's trying to run the macro, which is called well, compiling pattern inline typed field yield. Yes, this is a pattern type field. Yield is type. Yes, exactly. That was evaluating shit. And this was expected to be an AST in the end. I think it's something because of the macro, right? Inline. Let me see. Built-in function macro. Like, is this the one? If this is a syntax for the built-in function macro. Hmm. No, hold on. This is still supposed to work. What? I need to like... Okay, let's and I need to like split the standard library into multiple files too, my own standard library, and to have a way to import files because my standard library is too big. I want to like try working with just a syntax or I don't know, something without like specifying a lot of things here. For all yield this type. Oh wait, hold on. While compiling the binary this importing file and another step closer to kast.mummy. Yes, importing files is going to be huge. I need to do that so that I can split my like because my standard library is also growing slowly, right? So it means that I'm compiling something and then like I think it's like the priorities here are While compiling, operator binary. This, libks 89. Wait, what? What are you compiling though? This makes no sense to me. So I'm compiling the then at 31 into 399. Over here, this is the very beginning. So I'm trying to compile the entire thing, is what it says. The next thing is trying to compile from here. The next thing is trying to compile from there. Yes. I mean, that makes sense to me. Maybe this is because it's showing that it's trying to compile the syntax, and then after the syntax, it has something else. 10 push-ups? Alright, sure. Oxygen for brain. Nice. So I'm compiling some shit. Pulling macro placeholder. File. Filing. AST name. Yeah, how about over here? I will say syntax. Yes, that's exactly what I'm seeing there. All right, that is fine. So like we have a bunch of syntax definition, and after that we have a bunch of actual thing. We have const let yield resume, right? So I'm trying to compile a pattern, inline typed field yield type, right? Right. So I'm trying to call the macro inline typed field, right? Let's see. Expand compiler expand macro. Right? Expand macro. That means that I'm trying to get the local value, and then I see that this local value is a macro, right? Call macro info. Maybe I should have an info here. So what am I saying here? I'm calling macro with name being yield, type being type. I'm calling a macro with type. Am I calling wait. Calling a macro with name being name and name being type. Wait, what? There's name. His name. Type. It's like the inline field. The priority is different or what? I guess the priority is different, right? Because I'm calling name is yield and that is type, right? So this is what's happening. What is another? Why am I calling it another macro? This is a macro which is called inline typed fields, right? Inline typed fields. stdlib. Inline typed fields is being expanded into name, being name colon type, right? Name is name colon type. Oh, it's because I have inline names here. All right, this is what's happening here. All right, because I'm using the inline field already. Okay. So I know that the name is AST and type is AST, right? And this is supposed to be like inferable anyway. Wait, what? All right. Should I report this to the Helix? Hold on. This is the first time that Helix ever actually broke for me. Look at this. Thread main panicked. Helix score. A source transaction. RS. You had this too? Did you report it? You think it's fixed? Maybe? Like in the new... Like I just need to update this stuff? Helix score, source transaction, this thing. This is still an open one though. Unless it's a different one. Find completion range off by 1. Fixes. Is this like fixing a different issue? All right. What I was looking at anyway. Forgot stdlib. All right. While evaluating AST, evaluating AST, while evaluating AST. What is the problem? Is the problem with the fact that type? I think that, wait, hold on. Is the problem that type is a built-in type? No, there's no way. That does not make any sense. Unless I have a syntax type. Or something type. No. Type expected to be an AST, but got type. So it was like actually evaluated instead of being evaluated as an AST. Why? Why? It's not a macro return, not an AST, right? What is the problem again? Expected to be an AST. Expected to be an AST. It's in the interpreter when I'm trying to evaluate the AST. What will I use my new language for? I would like to use it to make games. But maybe first, like that's a long-term goal though. I think. The short-term goal, maybe before... I mean, technically, I don't know. Like if I compile it to JavaScript, then I can start making games like pretty quickly, I think. I figure out how to do that. Otherwise, I could also like start by using it for solving like leet codes, code forces, some shit like that. Like an advent of code. Where's the advent of code? It's all usually like in December or something like that, right? Like 2023. When is it? Events. 2023. Does it not show the dates? About calendar. Yeah, the 2023 is the last one. I think it was in December or something. So like, yeah. Trying to fix the bugs, to do anything with it. Inline typed field yield type. I understand. But at the same time, I don't. How about I do over here? Try with failure. Raise failure. But I will do something like log error while calling macro with go args. Is that the thing? Args is called values, right? So is it while I'm calling the macro, or is it not? While calling macro with, yeah, I mean, yes, this is what's happening, right? But not the inner macro. So I was evaluating AST, and I have AST inside an AST, right? I would, okay, so they're saying that, okay. Let's go to the standard library and let me comment everything out. Comment everything out. I'm going to go to the very beginning, to the very end over here. And I'm going to comment all of this thing out. Okay, so how about I do something like this? I want to do this. Quote type. Double quote. So this is me in the quote. The type, right? That's what I want, right? If I say that type is quoted type, right? Then type is the yes. Okay, so this is wrong. This is wrong. This is wrong. If I say quoted type, it is yes. Okay, I understand now. I understand now. It's because I call a value called type, and it does not, like, it doesn't shadow the existing type. It's because of the shadowing right now. Okay, I understand now. I understand now. It's because I did over here get local value opt. This thing is trying to find it in the built-ins first. But I guess this is like a hack. I don't even want to have this at some point. I guess I'm going to do this. I'm going to remove that completely in case I do not find it. Then I'm going to find the built-ins. Otherwise, let's find it like that. And let's have a to-do here. To-do built-ins should not even be looked up here. I guess. For now, I will do this though. Okay. Function input not found in a map. Okay. So now, and yes, over here I'm finding something like built-in space name, right? That's what I'm actually finding. I guess. If I have the built-ins, is built-ins all, right? So built-ins all, built-ins, I am adding a built-in macro here, but let's just add a macro space, and let's just add a function space here. There you go. So now it's going to say something like, built-in macro then is not found. Yes. Okay. I'm going to change this thing 1,000 times. Let's see, over here I want to, okay, how about I just change everything, which is like built-in underscore macro underscore into add built-in macro this. No, this. Okay, this is going to work, right? And then if I have anywhere a built-in function underscore, right? Then all of these should be changed into add built-in function this. Go to the end, add the quote. Okay, there you go. And we do this. Built-in macro then is not found. Okay, so why is built-in macro then not found? This makes not a lot of sense to me. Interpreter, if I try find in the macros, because built-ins should have a macro space something, right? Macro and macro name. Yes. If I have an interpreter, built-in built-ins. So yeah, I'm trying to find the built-in name. Well, I mean, okay. I see though. No, hold on. Over here. I was trying to find. No. I need to remove the built-in here, right? Okay. So I guess that match strip prefix prefix is built-in space name with some built-in name. Then I'm finding the built-in name. There we go. I don't add, I remove, right? And then if none, then I return none. Okay, there we go. What is wrong right now? Unbound module none. What do you mean unbound module none? Hello? Okay, built-in macro type of is not found. Okay. stdlib type of. Built-in macro type of is hard-coded right now. That is why. I have a couple of hard-coded things, right? Let's see, built-in underscore. Let's find built-in underscore starting with this thing. Yes. There you go. These are the 4 things. I need a built-in macro type of. Then I need a built-in macro unquote. Lazy Saturday, compiler work, pork. Let me watch you instead of doing my own compiler work. Is it Saturday? Oh, it is. Shit. I didn't know it was Saturday already. Could just VGE CC. I cannot like if you talk about like the when I was compiling my standard library is in my language, so CC does not work for my own language yet because it's trying to insert a double slash, which is not how I do a comment. Because I need to tell the Helix to like know how to. How to do shit. Built-in macro. Write all. Okay, it works. Parse 1 to 3 plus 1. It was not. I broke it. I broke everything. Okay, how about I try print 1 to 3 void. Okay, nice. What I say 1 plus 2. It says not inferred. Wait, did I do the add to be polymorphic, or did I not? I don't think I did that, right? Binary plus. Binary plus is a function from int into int. Yes. You just tried it and it worked over here. Yes, but like it does a double slashes for me. Double slashes does not work. I need a hash for my comment. It works, but it assumes a different thing. Maybe I can set it to a specific language. Set language Python. Right? There you go. You have syntax highlighting now. It's a little bit wrong, but commenting out should work properly. Is this how I should do it. What should I set the language to? Maybe something else. So is it the type inference that is broken or what? Just REPL. What if I do 1, 2, 3 int 32? Not inferred is not a number. Okay, I guess this is a little bit of a problem. So this is supposed to be. Okay, let's see. This is supposed to be inside the inside the built-ins. Type ascribe. Type ascribe is a built-in macro to this, and I do inference set the variable, which is the type variable, this thing to be that, right? And yeah. Why is that not work? How about I do log info ascribed with show type. Let's go here. If I do 1, 2, 3 in 32, I ascribed with in 32, which is and then I'm trying to evaluate the number, and it says that it is not inferred, right? So why not? Because I'm setting this variable, right? Let's see. It's ascribed. Inference dot show ID of the variable, right? So what is the variable that I'm trying to do specifically? So the variable is 2063, but the 2064 is the actual one, right? 1064 is the actual one. This is a built-in macro. Which is compiling this thing and giving me that stuff. What if I do? I think the numbers should be the same, right? 2075, 2076. No, it looks like I have a little bit of the RNG there, but okay. 63, 64. It's different by 1, right? Okay. Compiler number over here. This is what I have, right? Initialize number over here. It says data is unknown, right? Right. Is it wait, is like initializing it again for some reason? No. How about I say this here? What I say this here, let result be this in result, right? Can I say something like log info initted number with show ID with inference dot show ID data result dot type var. right? That's what I want. So I initialized number with 2069. Nice. And then I described it with the int32. So like, why is it trying to be at 2070? Right? Because it was what? Was it like set to be equal to something else or what? I don't understand. Where is the 2070 coming from? Where is the 2070 coming from? I'm making a new variable somewhere. Let's take a look at the inference set. Did I fix my inference when I was refactoring anything? Set and set. That variable. I'm just doing the unition, right? The unification. Unite. Right? How about I do something like over here, log info. Uniting. Show A and show B. Right? What do we do this? So if I clear and I do this, it did not do any unification here, and it should not be doing that. So where is the 2076 coming from? Var new and new var. That new var. There you go. This is the new var. Let's search for inference dot new var. Where am I doing this? Pattern to value. Value to type. Place folder. Placeholder macro, new function type variables. I don't need any of those. Type into variable. I don't need that. Initialize. The unknown. The match. The call. The field access. The initialize pattern. The template to template type. None of this makes sense to me. Let me do this. I don't need that string empty. Just so that it's easier to understand. While evaluating number, it is not inferred. What if I do int32? Oh wait, hold on. I know why. I know why, right? Because what is int32 anyway? No, int32 is a type int32, which is a type. Yes. This is still saying that it is not inferred. Yes. Hold on. No. The type itself is known. Okay, let's go into the inference. Let's say let new var be this. We'll say something like log info. Let ID be this. Log info. Making new inference var ID show ID. Right? We do this and if I do this, I actually create 3 things. Why am I creating 3 things? So I'm trying to I'm creating 3 things. Okay. So let's say that init compiler init over here. I'm going to say I already have it. This should be info. Initializing that stuff, right? Okay, I'm initializing a number and I'm making a new inference variable 2059. I am initializing a binding, making a new inference var 2060 because this is a binding. Oh, wait, hold on. Is it because this is actually a binding? Instead of it being a constant now, that's the difference, right? Yes. Maybe. It's a binding. To the name in the standard library. Maybe? Wait, what? Why is it a binding? Okay. Binding. In the compiler. In the compiler, binding. So you're saying that I am okay. So type in the built-ins, right? I'm doing the this type description, right? I'm doing the show type, right? Show type, value type. Value type can be a binding. If it is a binding though, we'll just say that it is a binding actually, so no. No, wait, what? Who creates the binding? I'm not having a let, I'm not having anything. Compile kast over here. How about word not found in the dictionary and encyclopedia? Did you mean caveman? Caveman not found? Did you mean caveman? Basically the same thing, yeah. Let's do this. Let's have these a lot of logs. So I have a built-in macro, type ascribe 123 with being void, right? I'm compiling AST to this, which is 123. So I initialize the number. I know that 123 is a number. I'm making a new inference variable for it, which is 2069. Then I'm compiling AST to the representation, which is being a void. This, became a binding, then okay, I understand now that this became a binding, but I was supposed to also evaluate it, no? Like, where is the ascription happening? Built-ins. Let's do this. So I'm making new inference. I ascribe this with void. 2073, which is exactly the type of a number. Wait, what? Hold on. Initializing the binding? Kuvi is a Dravidian language spoken in Southeast India. Trying to do a 2074 here. Making new inference variable 2074. Wait, what? I was initializing, yeah, when I'm initializing the binding, I already know that I'm not going to make, right? Because in the compiler, if I see a binding, over here, then I know that the type is the same as the value type of the binding itself, because I already know it, right? So yeah, I'm not even making. Okay, when am I making the new things then? Because the type, so I'm compiling, I'm initializing number, and I'm initializing the binding. Those are the only two things. Wait, what? Who is making new inference variable? I don't understand. Let's say initialized. Let's have this also in the logs. I initialized binding void. It is type void. Wait, what? Binding void? Is type void? But it's not, right? 1, 2, 3, int 32. Binding int 32 is type though. What? Something is really confusing right now. I initialized the binding, but I did not finish initializing the number yet, right? No, hold on. I did finish initializing the number. I did finish initializing the number, and I did finish initializing the int32. This is that. And then the final thing before evaluating. What is the final thing before evaluating? Type description. Set var. Type tip. Value. This is not making any variables. The value that I return is the expanded macro, which is a compiled stuff. I literally have nothing other than the type description, right? So I'm doing interpreter, and I'm doing evaluate this. It said while evaluating that stuff, right? So let's instead say show it fully. right? That's going to be the same thing, but it's going to tell me a little more. So I'm evaluating 1, 2, 3 of type int 32. Okay, I understand now. Wait, what? I do not understand. While evaluating number. 1, 2, 3. I know that it's of type int 32, right? I already know it. Wait, what? Hmm. Yeah, let's check here. Number. I'm trying to get the type. Okay, I understand now. I understand now. Okay. Whenever I was replacing the get inferred with get type, it was completely wrong. Inference.get inferred as type. How about this? Inference, module inference. Hello, Aragon. I should not use the get type, I should get inferred as type, because get type is the type of this variable. Let me actually rename this. Get type of variable. Is going to be return value type option. And then I go into the inference. Say get type of bar. And I say and get inferred as type. Var is get inferred var into value to type. Value to type is part of the what? In the utils? Yes, it is. Okay, this right now does not depend on the utils, right? Right. Utils, modules, utils. Okay. Kast ML. The inference should depend on the utils too now. Okay. Okay, now we have this thing. So instead of saying inference.get type, this is the type of value. Get type of var. Okay, I think this is like almost the only place where it should be. Value to type. Tills value to type. Signature mismatch. Something. Expression has type value option. Yes. Option map. Yes. Okay, there we go. Unbound get type. All right. So this over here, the result, type var. So this is not get type. This is get inferred as type. Okay, nice. Get inferred as type. This is the thing. This should just give me the value type directly. Get inferred as type. I'm just going to match. Get inferred with some t. Utils value to type t, and if it's none, then it should be infer var. Is that so? Unbound variable get type. It is also get inferred. Get inferred as type. Type of. Get inferred as type. An alias for something. Because the utils instead of get type, this is a placeholder. So I infer it. And I get a get type of var. What's alacrity? It's the terminal emulator that I'm using. Okay, nice. Nice. Log. Fun. Let's change info with trace now. I think I fixed it. 1 to 3 int. Okay, let's see. Parse 1 to 3 plus 1. Doesn't fucking work. There's a problem somewhere else now. What if I do 1 plus 2? I'm evaluating the things where left-hand side is not inferred and right-hand side is not inferred, right? What about just having a function, you know? Binary operator plus, right? Binary operator plus is not found in the current scope. What is it then? It is op binary plus, of course. So let's try op binary plus. Op binary plus is a function from not inferred into the not inferred. Okay, I understand why. I think is it the same problem? Even although I specify this here. Let me see where I am. Yes, it is a built-in. Okay. I understand why now. So like previously, I had actually like a function here telling me because like I went through any direction, the type was known, but now because this is equals to the built-in, I get the actual value of this built-in. So even though I specify the type here, it actually does not matter. Okay, so in the let's go to the types. Let's go to the value, and let's see. So I have one of the things that I have as values is a built-in function. Built-in function is something that does not have any type information attached to it, and I think I should. So built-in function, when I construct the actual value with it, I need to have the f. I need to have the type. This is going to be the value type. Like now I know what is the actual type of this thing. Kind of. Right? Yeah, I think so. Like I need to know what is the type of this. Because the same built-in function can technically be treated as different types. Built-in function. What is this here? This is a delimited block. Diagonal notation. Well done. So my built-in functions actually should know how to treat themselves. Like if I know what the type of them are, function type. So if I know that the type of this built-in function is function type, then it's this, which is going to have context inside too, right? Then list to do does not need to be here anymore. Value built-in function, should it be like even not like fn, but should it be like function type actually? What is the actual function type in the end? So for example, print is a function that is only expecting to be a string, expecting to get a string. So I'm going to have to say fun function type as, and then I match as with, right? Because like I do not care here. Okay, now I need to go through over here. This one, function type args. No, hold on. Dictafan is going to return function type args into match args with. Okay. Function expects too many arguments which have type. This, that. Yeah, this is a function type into value to value. Yes, there we go. This now float function is also not a function. It is a function type args into match args with that. Similarly here, this function fn type. This is returning. I just return function here like this, right? This is the same stuff. Okay, this is the same stuff. Okay, next. Single arc function. Single arc function. So f function type. Oh, see, function type. Different fn type. And then over here f2. Okay, does that make any difference? dbg function fn type. So yeah. Okay. Next. Next function type equal fun fn type into function. Random int 32 fun fn type into function. Random float 64 same fun fn type into function. This fun fn type into function. Okay, this fun fn type into function. This fun fn type into function. This fun and type into function. I mean, it's all like the same, right? Built-in function. F is this, right? Is this? F and wait, what am I doing here anyway? Huh. There's a lot of red squigglies. That's how writing code in OCaml feels like. Dict over here. This function type of a delimit block. I should know the function type here. Then I should be able to know the type of resume. This function takes as an argument, since this is a delimited block, this should have a handler type, right? Or something. Let's just I'm just going to be lazy for now. I'm not going to do this correctly here. I'm going to do this into function type vars to type for this, and this says to do actually set correctly. Okay, I don't think it matters for now. It's pattern delimited yield. Type into function. Function underscore underscore. Function underscore. macro? What? What is macro? The infamous to do this properly. uh, there's too much things that I'm touching at the same time. If I'm going to spend time doing this properly right now, then I'm going to forget what I'm doing. Is the problem, you know? Uh, so I mean, yeah. Mm. I just have 3 errors to fix. But yeah, this is how I plan to do, like, so instead of having multiple functions, string to float 64, string to int 32, I can actually like inspect this function type that like is inferred basically and make this function actually polymorphic. Built-in functions being polymorphic instead of having like 10 different functions. Yeah. There will be the functions for these ones. The type is what? I am inside the built-in Zfn, right? We have access to the compiler here, right? So new function type variables into function type variables to type, right? And this, okay. I think this should be good enough. But when I'm inside my interpreter, when I am evaluating the built-in over here, I'm not only getting the value of the built-in, I know that this built-in was expected to be of a specific type, right? Um. So So yeah. Dun, 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 dun. I guess so. Over here, I need to like set the type of the built-in to be this type that was inferred instead of the actual type of the value, right? By having this, but I'm going to match okay. Destruct. Nice. This is what we want. Is what we want. But so if I have a binding variable, infer variable, something something, right? This all doesn't know. I mean, yes, this is a built-in. Built-in. The only thing that I care about here, I think, is the built-in function. So I remove this from here, and I say that if I actually find the built-in function, f, then what I do is I return the built-in function f. But the built-in function f has the has also the type associated to it right now, which is like, which I'm going to ignore here. And over here, I'm going to say that the type of it is so I need to convert the data type variable, right? The type is not a part of the built-in function constructor. Is it? This is a value, yes. I want this to be a value. Hello? Yeah, Camel is sometimes stupid. This expression has type inference var, but I wanted to have type fn type. Yes, yes, yes. So now this must be in. So when I say that I want to use a built-in function, I must rely on the inference algorithm here. So I'm going to match. I'm going to match. Let's see. Let inferred movie boy shall seashore. Hello. My inference dot get. No, not inference, not my inference. It's just inference now. Finally, dot get inferred as type data type variable. So now I know what is the inferred type, right? And I'm going to over here match on the inferred type. We call this specifically inferred type. So I'm going to match on the inferred type, and it's supposed to be a function type, right? Otherwise, I'm going to say fail with built-in function was inferred to be not a function, question marks. What am I making? Type inference? No, I'm wait, what am I even making today? I'm trying to fix my stuff. All right. Oh, bad cop. Type inference is already there, but I broke it because I was refactoring my entire code base. And I forgot what I was even doing. But I think the idea is that I make my tests or something like that. Yeah, I didn't do much progress except for, yeah, I was basically like refactoring. So doing nothing today, I guess. That's what I'm doing. Why do we ever need to refactor anyway, right? Just like it was already working. Why did I even start doing that? Just do this for 7 hours with no results. All I do is breaking the things that already worked. How do you make big game? You start small and then you grow. Bad cop. That's how. But you don't want to start small. When you steal. Then you steal something big. That's also a possibility, I guess. Built-in function. This pattern variant is expected to have type value type. There is no construction function. Is it called fn? It is called fn. Nice. This field name is not part. Built-in function. This is type constructor. Okay. Yes. Let's see. Built-in function. Built-in function f is this. And then also I say that type is what? Argument type is equal to the variant. And then result type is equal to the one-off type, like the actual thing. This over here. Oh, it's called type already. Already matched type. And then the context is empty context. And empty context type. Over here, this is ignoring the function. Nice. Okay, 4 more errors. This eval call f impl using f type. ff name. Okay, good. Just value f. This form is not allowed as the type of the inline record would escape. Built-in function f is f underscore. Like this is supposed to be removed at all completely, right? The record pattern especially when built-in fn. There is no built-in fn. Built-in fn, just value built-in fn. Built-in fn. Yes, okay, I understand now. Built-in fn. And this has the data, right? This has the data, so I have a f over here. The type of language I'm making, the best kind of language, the language, the one language to rule them all. I don't know. It's you can see briefly what I'm trying to make on this website here that I made recently. So ugly syntax. Wait, this is OCaml. This is not my language. All right, my language also has right now pretty ugly syntax, but yeah. Wait, is OCaml ugly? Is OCaml considered ugly actually? OCaml is a functional language. Isn't functional languages like considered beautiful? All right, what is the beautiful language in your opinion? Never looked at OCaml. Bash is beautiful. JavaScript is beautiful. Oof. Oof, bad cop. Looks funny though. The OCaml? Okay, so my language, we can make it look as both JavaScript or Bash or OCaml. Because one of the features in my language is the syntax being dynamic. You can define your own syntax like this. If you like your ternary operators with semicolons and colons, with question marks and colons, then you can do this. Because you can define your own syntax if you really want. You can use emojis instead of keywords if you want. You can do shit. Please don't do JavaScript. I will not do JavaScript. We have static typing, which is why it's taking longer than if I just had a JavaScript here. JavaScript, implementing JavaScript would probably take less like a couple of days, right? What's there to implement anyway? Everything is just an object, and that's it. Go to settings to activate Linux. Nah, I don't have money to activate Linux. Okay, I need to do the same here, kind of, right? I need to do the same over here. No. Let's say type is new type vars into the function type vars to type. This is the same thing as before. This is going to be a to-do setup type properly. Although I think it's like to do, although this is to be deleted, question mark, completely. This part of the intermediate representation is going to be deleted, I think. So maybe I do not need that. Okay, then I have this unbound value name. All right, built-in function. This is going to be f equals to name with underscore and underscore like this. Okay, nice. Okay, it looks like it compiled. Okay, let me see here. You've been trying Odin too? Okay. Let me show you guys if it is going to work or not. There you go. So this is a language. As you can see, I just go into the REPL. Even although the language is compiled, the language right now it's being compiled into its own intermediate representation which we then evaluate and interpret. But the idea is that I would be able to further process this intermediate representation into a compiled program, like a fully built executable. So right now the only backend is the interpreter, but I want to be able to compile to other things too. I want to be able to transpile the language into other languages. Like the JavaScript is going to be actually the first programming language, the first target for compilation. But for now, we do the interpretation. So if I say something like 1, it's going to say that this number is not inferred. I need to be able to know what the number is. If I specify that it's an int32, then it will be an int32. Or if I use it in a function that uses an int32, then it's supposed to do this. But once again, I have a bug somewhere. Because the plus right now is not overloaded. It is supposed to be specifically about the integers. Okay. Is there anything that works? I mean, print 1, 2, 3 should work, right? If I do a parse 1, 2, 3 into an int32, then it actually works. So I actually like parsing works. Okay. Is it specifically the plus? Specifically the plus. Let's see, built-in not the built-in, just operator binary plus. Operator binary plus is the one that is not inferred still for some reason. Why not? Is there anything that works? Yes. I mean, this is the only thing that I'm trying to fix right now, I think. The plus. This is a built-in function, but it is supposed to be polymorphic. But because in the standard library, I am saying that binary plus is a function which takes an integer, and in both sides, it's supposed to... It's like losing this type of information right now for some reason. Okay, so why? Why? It's in the interpreter when I evaluate. This is it. No, this is not it. It's over here. The data, right? Data. Built in. Maybe it's because this was not evaluated to be a built-in or something. stdlib. No, this is supposed to be a built-in function binary plus, right? So over here, let's see, log info, built-in inferred as a built-in name inferred as show type inferred type, right? So when I do this, built-in binary plus inferred as this. Okay, hold on. This works, right? It actually did work. Plus is int 32, int 32, int 32, right? Wait, but it still is, but over here it still is not inferred. Why is it over here then not inferred? Because this is just like a variable which is assigned to this built-in binary plus, which was inferred correctly here. All right. Points scammed again? You mean, yeah, I did not add your comments? Okay, sure. Is there anything that works? There we go. So built-in was inferred correctly, but then, like what? When it was assigned? Or what? What if I over here? What if I do it over here? What if I do it over here? Let's see. Look, trace. What if I do over here? Log info. Built-in. Name is equal to show value. How about this? Because this is supposed to show value. Oh, okay, I need to like show the type, right? Show value, and then colon show type, type of value, right? That's what I want. Type of value is value insurable. Okay, ensure false. Okay, let's see. So yes, okay. So binary plus, it's a built-in function binary plus, which has the type not inferred into not inferred. That makes no sense because, okay, I actually know why. It's because type of value is implemented incorrectly right now. Let's go to the compiler and let's find the type of value. This, if I have a function, if I have a built-in function specifically, this is supposed to, yeah, over here. This over here is incorrect for sure, yes. So built-in function, I need to know the type here. I need to know the type. I already know the type. And over here, this is the type. There we go. This should fix it. Let's go. Inference union failed. So now something was inferred to be something wrong. I was uniting type and void while uniting something. Isn't it supposed to be like while I'm compiling something too? Arg void result type and arg type result void. When exactly is this happening? Why are you uniting values? Supposed to say that while I'm compiling or something. No? While uniting values, type arg void result type. While uniting something. All right. Let's see. Evaluate in the interpreter. Let's do this. I'm going to let's do a try here. Let's do a with here. Failure underscore into raise failure as failure. Please. I want to say here what? Log error while evaluating file name. File name. I mean, this is not really going to help me much, right? Because it's just going to say, wait, what? It doesn't even say while evaluating, right? Why does it not say that? This is weird. So is this after I evaluate? Is this outside? Somewhere. Oh. This makes no sense to me. Let's go into this here and let's have the OCaml per run param be something something. What's my stuff here? So I'm compiling AST to this, right? Since it is happening inside me compiling AST to the intermediate presentation, why am I not seeing it in my logs? So it's a built-in type ascribe. I'm compiling. I'm initializing. Something. Compiler 288. Compiler 288. Over here, this, I am calling an actual function, and I'm trying to like run the for the type inference. I'm setting the type of a function to be a function. And I'm just making the argument type to be the type of the argument that I'm calling the function with. Yes. This all looks correct to me. What I don't understand is why I don't have the logs. This now makes no sense. Oh wait, hold on. It's because of the failed unite. Failed unite is not giving me these things, right? While uniting. Yes. Hold on. It's because, okay, so the inference over here, when I say the unite, it's going to fail unite, right? Yes. Let me call this, rename this into unite value, right? Why do I not have the errors right now? Inference. Did it actually? Oh, I know why. Okay. Okay, understand. I'm never even saying this. Okay, so this function is being called over here when I'm doing the set. I'm just going to call unite. I'm going to call the unite here, and then I want unite value. I want this to only be called from inside itself. Right, and this thing is I'm uniting the types. Okay, yeah. So and unite is function A value and B value returning value is going to be equal to try unite values A and B with fail unite fail with inference failed. I don't even know why I made the custom exception here, because it's not really like helping me do anything except for not catching it on accident. Okay. I think I can remove these logs. Okay, so I'm compiling something. I'm compiling macro let at stdlib 147. Okay, now I know. Let's do this. Stdlib 147. This, the input. The input is the built-in function input, right? Is that what to... So like over here, I'm specifying that the type of this is void into the string. And what is it actually conflicting with then? So void into... Wait, hold on, what? 147 into 148 is what I'm compiling. It says, so I'm calling. What am I calling though? What am I calling? I'm not calling anything here, right? I'm compiling pattern, built-in function, function type, string into void, right? Okay, so yeah, okay, so string into void is just me. Okay, I see, I understand now. I understand, I think. So this over here, this arrow is just a function which takes two types as a value and gives us a new thing. But built in. So because this is a built-in function based on a syntax, I think this is supposed to, so like I should never have, basically, let's see, syntax which is based on a built-in function. This should never happen. No link cider break yet. Hold on, I feel like I'm almost done. You know, I'm almost done. Right? Right. I am almost done. Right? How many of these do I have? I have function type, and I have macro, I have or, and that's it. Actually, I don't have that much. It's going to be easy. No sandbox build anyway. What do you mean no sandbox build anyway? I have a build of this language. You wanted a sandbox build of the link cider? I see as Buix. I didn't know you stream. What do you stream? Mm -hmm. Restructuring Rust. I've raided once. Did I raid ICS box before? Oh, how's it going with the compiler? It's almost working. It is almost working. All right. 1 second. Built-in function macro. So built-in function should, like all the syntax, should actually go to the macros. But this macro specifically should I say that macro is actually like more like a function, or like a macro instead of a function. Because if this is a built-in function, then actually, you know what? I think I can compile it into something different. So here's what it happens, right? So when I have expand AST, right? I know that this thing expand AST. Compile AST to intermediate representation, right? When I do this, and I know that it's something complex, then I do an expand macro. Expand macro can actually work with functions still. But if it is a built-in function, then I'm going to compile it into calling not the const value behind the built-in function, right? I think in this case, I need to compile it into a little bit of a different thing. Let's match value with built-in function built-in function f, and so like the type of the built-in function in this case I am going to ignore, and I'm going to replace it with a new one, right? Like the value can be, wait, what? No. Yeah, I'm going to replace it with a new one. With, so if it was a built-in function, then okay, where's my problem with the syntax now? I have function, I have type, underscore this, that, underscore into that. Where's my problem with syntax? Syntax error. Match. Oh, okay. Const value is equal. There we go. This is what the problem is. So if it was a built-in function, parameters are undefined data. Yeah, this is supposed to be this, right? So now over here, we're going to replace it with a built-in function f, where type is actually the new one, right? New function type variables, function type variables to type. Okay, hopefully this is going to be good enough. Okay, I am in the REPL 1+2. Fuck, it doesn't work still. It's REPL. Okay, let's see here. Built-in binary plus. Okay, hold on. Binary plus is actually a function that takes the integers, right? Okay. So if I say binary plus with the left-hand side being 1, 2, 3, and the right-hand side being 4, 5, 6. I'm supposed to use not the curly brackets, but then these ones here. Then it actually works, right? Even though I don't specify the types of the numbers here. But if I do the 1+2, then for some reason it still does not work. Okay. Wait, hold on. I know why though. I know why though. Yeah, I know why. Wait, hold on. So, okay, hold on. So built-in function can be in one of the two states, I think then. Built-in function can be in one of the two states. We either assigned a type to it or we did not assign. So this is going to be an option then. Function type option. How about this? So over here, for example, right, when we do a resume, this thing is going to be none. Let me keep this comment though. I think this comment for this specific one is good. This though, the built-in functions, if I get the value to it, and I get the value of it, it should not yet know in its own type. Okay, then over here, built-in function. Okay, this is where where am I? Compiler. So the built-in function, this is what I want, right? Function type vars to type new function. Yes, so this over here, I'm going to match type with some type, then type. And if none, then new function type vars into function type vars to type. Wait, what? What's the issue right now? Match, right? There we go. Built-in function, compiled const value, built-in function, type is underscore. This is where I am expanding this, right? Since this is a built-in function, I think I should actually preserve it, but it might not be known. In case I call the known built-in function, then it should be that. So I actually just say that value is value. I'm going to redo this. I mean, I'm going to undo this change here. This problem is going to be the type. To do constructor type. Archetype variant type is. So over here I say sum. Actually, the constructor type is being set here. This is exactly what I'm doing, right? The variant into type. Okay. This function value type. Eval call. Try call. Function type. So this means that the function, when I'm calling it, potentially does not know that thing. So I'm going to, I guess here, match function type with some t, then t, and if none, then new function type variables into function type to type, like before. This says if the inferred type is function f, then the f, otherwise none. So this is the built-in. I matching the inferred type with function f. In this case, I say sum f, right? If I have a built-in as a yes. Okay, it must be inferred in this case, I think. That makes sense to me. If I have a built-in function, this one, then this is going to be none. Okay, build finished. Okay, is it going to work right now? First try. Just treble. Let's see, 1 plus 2. There you go. There you go. There you go. What if I do parse 1, 2, 3? plus 2. This is going to be 1, 2, 5. If I do 1, 2, 3 into a sign to get a sign of this floating point number being parsed, then it's going to parse it into a floating point. All right. And I was doing all of that. What for? I was trying to do something like Nix flake check because I was making my tests with Nix. Okay. So now it says built-in function is the same type is not found in the current scope. Built-in function is same type is not found in the current scope. Okay. Built-ins is same type. It exists. It exists and it is in the list of my built-in functions. Built-in function is same type is not found in the current scope. Is not found. Is not found. Not found in current scope. There is 2 places like this. In one of them, I do the get local opt. In the other one, I do the get local value opt. So I guess this one is the one that doesn't work because when I compile to AST and it is a simple one, built-in function, because it's a simple token, right? Is same type. Let's see. Maybe I think I just need into the standard library is same type, right? This should be. I should just call the function is same type here. And is same type should be defined in the standard library. So is same type is a thing which takes is a function which takes a being a type, which takes a being a type, and b being a type, and it is a function that returns a boolean, right? And this is equal to the built-in function is same type, right? And then it's going to be found. Built-in function is same type is not found in current scope. Because I am still using it here. Else if is same type, right? I also see over here that I have an else if with parentheses, which is looking really ugly, I guess. Figure that out. Inference failed, inference union failed. This is when I'm doing guess a number. Okay, so guess a number still is not working. This is going to be forever. But I'm getting there, right? I'm getting there. Let's see, just test, guess a number. This is going to say that the type inference failed. So I was evaluating something, and I was uniting types, never. Okay, so never, and okay, so the never is the thing that is actually like really bad. Because so like Rust has the never type, and never is something that can be treated as any other type. But at the same time, the type inference right now is not really able to do that. I have no idea how it was working before, but it is because over here I'm using a panic. Because I'm using a panic, and panic is specified as a function that returns never. That actually is this. But if I use a built-in, if I use instead a built-in function, panic, and then call that with the WTF, in this case, this is going to be a new polymorphic function, which is going to be inferred to return the same thing as before, which is wrong, but this is wrong. Make never type actually work. Yeah, for the never type actually work, I need to have subtyping or something, probably. Okay, 5, and then inference union failed again. Break, sure. Whoop. And the break is over. All right, I need to really like get it done and then end. We are doing this for 8 hours with no progress. We're undoing progress compared to yesterday, actually. Okay, anyway, we do inference union failed again because of the never type again. Okay, so the loop context, something, something. I'm compiling the value is void. Loop context, something is never. Again. I am united types, void and type this. Where am I using the never type again? The finish current iteration, this is where. Okay. How was it even like compiling before? I feel like I actually only exposed the bug that was there before. So the problem is the never type. Same as unwind. Okay, you know what? Let's make this back. Can I make the never type work somehow? So when I say that the two types, so for example, I see the fact that I'm calling a function panic, right? The function panic is something that is never returning, right? The function panic is something that is never returning. So I am seeing that the type of this else branch is never. So then I'm trying to see over here the random float 64. This one is supposed to return a float 64 here. Right, and it just like does not work because it cannot be both never and float 64 at the same time. How do they do it in Haskell? Haskell does not have the Haskell playground. Any Haskell people in chat right now? How do they do the what is the type? Is it a special type when you raise an exception? Is it just a like it's supposed to be like a polymorphic thing then, right? Never is just like a polymorphic thing. So panic technically should not return never. It should be like a polymorphic function which can return anything. That's how you do the never type instead, if you don't have subtyping, right? Never. Never. Loop context. Finish current iteration. But like, if I do it as a generic thing, then it's like another for all here or something, right? Finish current iteration. No, over here, this finish current iteration. Hold on, this is the for all, right? For all t. So like, it's almost like whenever I see a never, I should rewrite it into a polymorphic function which can return anything, right? Because it actually never returns. So finish current iteration is for all t, which is a type. It's a function. That returns type t because it's not a never, right? So can I do this? So this is not a never, right? Not sure if you understood, but in Haskell, if you have absurd void into a, yes, exactly. So like the a here means that the it's a polymorphic, like the return type can be anything. In Rust, they have a dedicated type which is called never. Rust never type. So like instead of this being of any type, of any like It's specifically a never type. You know, and it can be like treated as any other type, which is how it works, because this is one of the few things that has subtyping. But I guess yes, we can do it. You give me the contradiction. You give me anything back. Yes. But it's like it doesn't like it doesn't actually like I like the never type more because it is explicitly saying that this function is never returns. So in Haskell, by looking at the definition, you are somehow assuming that you still can get a value, but you actually will never get a value. You're going to panic. There is going to be an exception thrown. Absurd cannot run. No, it can run. It just cannot never finish running. It will like start throwing an exception. Well, I guess void in your case is different, but you have not the absurd. You have like you specifically have the how do you call exceptions in Haskell, the raise keyword or whatever. So when you raise something, what is the type of this? The type of this is more like if this is taking like a string, right? String exception, right? The type of this is string into a, right? Because this also will never this will never finish running, but it will start running. It will consume your string and throw an exception using that string. It's not the absurd one. The void that I use here is a different void. This is the void from C, which you call unit. So I'm considering renaming it too. Unwind. Unwind for all type T and R, then 2, right? Type. I don't know. How, like, do they actually do it with subtyping in Rust? So this is a function that returns any type, basically. Yeah, I don't know. I'm not a fan of this. Can I keep my never somehow? Can I keep my never somehow? What if I say... What if I say something like, in the inference algorithm, if I see that one of the things is never, then I'm just not uniting this thing, and that's it. What if I just don't unite them? You know? So when I make the variables be same, right? I am over here. You call in the unite, right? You call in the unite, okay. So unite value. Can I just keep them being the same? Keep being them. Can I just do? Can I just so like is the unite going to be an optional? So like it might actually not be unified then? Not always. Is that that potentially something that can work? Mm. Mm. So then in this case, I need to do something completely different. And to not even make them the same here, right? But inferred value, let's do inferred value and united. I don't know. Let's do this. In this case, I say that they must be united. Yes, in this case, I also say that they must be united. In this case, I say match unite with some let united be this in united, and option is united. And then over here I say if united, then I do all of these things, right? Okay, set variable. Data inferred is sum, unite, current value, and value. Only if I can actually do that, right? Data inferred. Some current value, then I am trying to unite them. So, okay. So I'm going to over here also match this with some united, it inferred, some united. None, I'm just going to do nothing. Okay. My unite values. So unite values is going to return value option, right? This is all going to return to me some finding a some infer variable. This is going to be some b. I feel like this is going to fail though somewhere, but I'm going to try anyway. BSD. Pool a some. Wait. But over here, I'm unifying the fields, right? So how is that even supposed to work? If something was not unified, then it is supposed to what? So if I have a never type, or maybe when I'm doing a union, the never should like, hold on, undo. I have another idea. I have another idea. I have another idea. What if I just keep, or like over here, when I'm making the two type variable the same, then I know that I have inferred it to be something, right? But over here, I'm setting something to be this inferred value, right? But what if it was a void? In this case, I will not override it. You know, and then when I'm unifying void with anything else, it's just going to be that, and that's something else. You know, so like over here, void, not the void, the never. Where's my never? Yeah, never is never, right? But if I have never, and if I have never, and the other one, or I have something else together with the never, then I should return this something other. You know, let's have this somewhere in the very top. Let's have this somewhere at the very top. Similarly to the infer patterns. Okay. Can they be, should they be here? Should they be higher? Yes, but obviously, like, I do not want to override the existing never, right? Right? I do not want to override the existing never. So I think we have this set variable, the set function, right? And I say that if my current value, like, I only need to override it. There's a value, right? If it's not the never type. Something. If match data inferred, match get inferred, match get inferred, root. So over here, if it is some type never, as current value, in this case, hello buffer. In this case, I'm going to ignore the result of the unification of the current value and the value that I'm trying to set to. So I can set this to never, but I will not overwrite it. And then over here, I will say a data is these are the two variables, right? These are the two variables, so I'm going to do I recommend a OCaml for writing my own compiler? I don't know. I don't recommend anything. I think OCaml is kind of annoying, but I don't know. I don't know what to like recommend instead. Like, I think I would recommend Rust, but like a lot of people are complaining about Rust, so like probably not. I don't know. I think Haskell would be a good one, but then again, I didn't really try Haskell myself. I have been reading about it, but I never wrote any big program in it. What about Go or Dlang? Well, if you ask for my personal opinion, then Go language is like the worst language of them all. The D language was okay when I tried it, I think D language deserved more hype, but it I don't know. I stopped writing it because even in the debug mode, the null pointer exception was a seg fault. That was my reason that I quit. Other than that, I don't know. I don't know. It's like Zig, but Zig is only low level. So like they have like the type level or like the compile time reflection similar to Zig. You can run your functions in comp time in D language too. So I don't know. If people like Zig, why did not they like D language back in the day? I don't know. Because Zig is a simpler one, I guess. It has less features. But in my opinion, it makes it harder to write complex software when you have not enough features. Do I have a compiler design in university? No, I do not. I know nothing about building a compiler. In fact, I have not even read a single book about making it. I'm just trying to do it as I feel like it should be done. But yeah. Random bool. Okay, so there should be something here. So if I have the two variables, and if one of them is a void, then I should not do anything, you know? So let's see. If get inferred. Okay, something. I think I should almost like just set A to be equal to the inferred value, right? And I should set B to equal to the inferred value. But this thing, the same as, should be done. Inferred value is not an optional, by the way. Wait, why? Is it an optional? If match inferred value with some value, then set A be value, set B to be value. If it's none, then I don't do anything. Like this, right? So this is going to update it if it's not a never. And then over here, this thing should be different. I should only do this if the inferred values are the same. Actually, after making them the same, they might still not be the same. I guess I can do, I only do this if one of them is never. If none of them is never, maybe. You know? If get inferred, okay, let's see. Match get inferred A and get inferred B with some type never underscore or underscore and some type never. In this case, I do nothing. Otherwise, I do this stuff. Right? Okay. Does that make sense? Let's try. Now it cannot infer something. While evaluating is same type. Is same type. Wait, hold on. While I'm evaluating. Cannot get ID for not inferred types. Is same type. A is type. B is type into bool. I'm trying to get the type of binding T. Type of binding T is that T is some type. Yes, okay. Yes. Hmm. Hmm. And I'm trying to see if binding t. So if t is equal to int32, this is what I'm trying to see here, right? And if, but the t right now is not known. But why am I trying to even call it right now here? That's another question. stdlib. So this is specifically talking about this. I am doing a compile time evaluation of this stuff. T is obviously not yet known. So is it because I'm trying to run guess a number? If I go into the REPL, I can go into the REPL. So if I go random int32, random int32 is not working, right? Because it's yeah, okay. So it's evaluating built-in random int32. It was, wait, hold on. It was evaluated to type never. Exclamation mark is the never. Built-in function was inferred to not be a function. Okay. Yes, something is wrong here. I think highlighting actually looks good on it. Yeah, not too bad, not too bad. I think right now the problem is the way I'm compiling some stuff. So like if I want the never to be working like this, I'm sometimes reusing the variables instead of creating a new type variable, a new inference variable, and making the two type variables to be the same. For example, let's take a look at the if here, right? And the if. I know that the data is same as the else case, basically, right? I know that the else case is like basically like the, so the then case and the else case must be of the same type, right? That's what I'm saying here. And then the result of the if statement is the same as the one of them. So in this case the else case. But if you look at this thing, then I'm just reusing the existing variable. But instead what I need to do is I need to do something like this. Let var to be equal to inference dot new variable, right? And then I'm going to inference dot make same my new variable and this other type variable, and then only after that I return this new variable, you know? So that in this case, if that one was never, like the result of the entire else is not supposed to be never, right? The result of the entire if then else. I should go through this thing. Built-in functions is inferred to not be a function. It is still inferred to be a type never. Okay. All right. I kind of need to end soon. Let me try to fix this in the next 10 minutes. If I cannot, then I'm just going to end the stream, all right? Because I need to go. This is 8 hours already in 20 minutes. The stream. Built-in function was inferred to be not a function. So how did I infer it to be a never thing? There's like more things like that, where I do not do the type variable to be a new one. So like, what exactly happened there? Let me see. If I have a REPL, right? And what if I say something like this? Let A, or let me do something like this: type of, if true, then built-in something of type never, you know, else built-in something else of type int32, right? So like because of that, okay, the never is not the exclamation mark in my code though. I need to actually say that this is a never, right? So yes, this was like inferred to be an int32. If I say on the other hand that on the right side we have the never, this is going to be inferred to be never. But if I am going to say the int32 over here, it is supposed to then say int32, but it does not do that. It does not do that. It does not do that. First of all, it should be not inferred because that one was a never, right? But yeah, specifically if we talk about the if over here, I feel like data is something like type var is var. So I'm going to instead make a new variable here. Let var be inference dot new var, and then I'm going to say make same var to be equal to the type var of the then case, and inference dot make same the var to be equal to the same as the else case, right? Like this. So this is supposed to kind of be the same, but so this is going to be int32, and if I say a never here, it's going to be never. If I say int32 over here, it's still going to be a never, because the first thing that I set it to be equal to is the int32, because why? Because why? Okay, let's see. So if I make the same variable, right? If make same, these are different variables, right? If this is one of them inferred already to be a never, if that one of them already inferred to be a never, then it's this, right? Okay, how about over here? I do log info united as show value Igorly. Hold on. I do this. It says united as type never. So like I was saying, the never should never be united. So that is the bug, I guess, right? The unite types. If I have a never and never. Kozlowski stepped on me. Is he like playing the game right now? Last night? Alright. I am united as type never. This should never exist, right? Wait. It does exist. Yes, hold on. Hold on. I should, like, this is the one that should not happen, right? I'm only doing the united over there. There you go. I think this is the way. Okay, there you go, there you go. So if one of the branches is int32 and the other one is never, the result is this. If it is the other way around, then it's supposed to be the same, right? There you go. Okay, nice. If I just test the guess a number, is it going to work? 5 less 2. Fuck. Built-in function unwind. Oh, okay, this is a different error. Built-in function unwind not found in current scope. I actually fixed it. Built-in function unwind not found in current scope. Let's go built-ins. Unwind. Unwind is a built-in function. This is supposed to be existing in my built-in functions, right? So why does it not exist? Built-in function unwind not found in current scope. Not found in current scope, right? This is because it is over here, like something like this, right? Get local opt. This over here is can be a built-in, right? Built-in function. Built-in function. Unwind. This over here. This is what needs to happen. So the args. Okay. So this should just be instead a built-in. It should be a built-in function unwind of type token into the never. There you go. Built-in function. Okay, I still allow this to be inside the syntax definition, but not anywhere else. Okay. What kind of job do I do? The jobless job. Function unwind not found in current scope. Function unwind. Built-in function. Oh, yeah, without the at, of course. Okay, there you go. Yoke system is jobless. No, I do a job. I'm making the like I'm just not having like your normal day job. I'm working as a contractor and I'm making the I'm making competitions for programmers. I'm making games for programmers. But this happens not very often. Like I can easily not work for a year, for example, because I do not have like a job for me available. I could do some other jobs, but you know, I can just stream. Anyway, look at this. The guess a number. It actually works again. Nice. 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 Lazy git. Let's commit everything. Nix flake check. This is going to run my tests. Any test that is still not working. It says exception end of file. In the guess a number. In the guess a number. Okay, I know why. Okay, so here's my test, right? So I have a test right now. Guess a number specified in Nix. It says that it's trying to read a number, but it instead gets the thing. So I need to provide it with the input here. The input is... I'm wondering how like the RNG works with Nix actually. Can I make the input to be like... so like it's going to say something like guess a number, right? And I'm going to say like 5, right? So what is it going to say? No such file or directory. Yes, of course, because this should be a built-ins dot to file input this. So it says that... Okay, this is a different one. The kast check ID. Check ID is I think this I already fixed, but then I undid some of my stuff, right? So it's like the built-ins dbg should use a double colon like in the other places, and then inside the main I should already use the double colon. Okay, go to this. Once again, run the checks. Okay, now it says exception end of file, because it cannot even like run to the end, right? So guess a number Nix should say 5, and then it should say exit. Exit is how we say that stop playing the game, right? Okay. So this is going to say a number has been picked, guess less. Guess again. So let's try guessing this inside a test, right? So it's going to be 3. Maybe it's a 3. How does RNG works with Nix? Anyone using Nix? RNG still is RNG, right? So if I use RNG inside Nix, then I cannot write a test for this, right? Because the list test is actually literally RNG. Okay, I'm just going to say the exit here then. And then I'm just going to say what the expected output there is, right? The expected output is a number has been picked, yes, and then quit it. And number has been picked, yes, quit it, right? This is my expected output because otherwise I cannot test it with RNG. How do you test a program which has RNG in it? But my currently all tests actually working. Okay. Okay. We have tests, guys. Look at this. I have the test of the mutability. I have the test for the ID function. I have a test for the Fibonacci. The seed. Yeah. Yeah, I need to like, okay, yeah. I need to like be able to seed my RNG. Yes, so I need to have a new function, which is a seed, right? A new built-in function, which is a seed. I'm not going to do that though right now, because like I said, I need to exit. This is already good enough. Let me just have a comment here, to do, use a seed to actually play the game, right? Okay, there you go. Because this already is going to be a huge commit. Huge, and it works. Nice. So like I have actual test, then I need to like also set up the CI so that the Nix flake check would run automatically, would be also nice, right? Yeah, and then I need to check out main, and then I need to rebase. Do I rebase? Do I like what? Rebase the refactor, because that's what I did today basically, right? Git push. Nix flake check. Nix just REPL. If I say parse 1 to 3 plus 1, it's still 1 to 4. If I say this into sign, and it still works. Okay. This is the one that I currently use to test my inference. Okay, what else do we have? I can do 1 2 3 equal 4 5 6. This is going to be false, and at the same time I can do 1 2 3 is 4 5 6. This is going to say that this is not inferred. Yeah, that makes sense. Unless, I guess, I specify one of these types. If one of them is of known type, then it should be able to run the comparison correctly. Okay. One of the types needs to be known. Okay. I think this is good progress. I'm going to end for now. Thanks for watching. If you are interested, what I am making, the website is over there still. We're getting there. We're getting somewhere at least. Okay. Twitch. Need to raid someone. What do we raid? Are there any Haskell streamers on Twitch? Julia language? Game engine development? What's a Julia language anyway?
Oh, my neck hurts.
Julia sounds interesting. But I don't remember what it is about Julia. Lang. Parallel and heterogeneous computing or parallelism. Nice.
I don't like the formats of these. I would love to do like file previews, but this doesn't seem like.
All right, let's go here.
It just looks like it's file names.
All right, I'm going to go eat some food and then
I just have to make it myself.
walk around and yeah, do the normal human stuff, you know. See you guys next time. Bye.